Okay, let me explain. And we'll I'm gonna switch us over to that static fire footage. I want to see this. I haven't actually seen a big, super heavy static fire yet, so I'll switch us over and I'll put it up there so we have it just in case. All right. Question: as you said with butane, the flame goes back and it overpressurizes. How does it stop that example happening in a rocket? Is that because the COPVs are maintaining pressure? No. Alleviate. There's these big things on rocket engines called turbo pumps that make sure the pressure goes in one direction, or make sure the fuel gets flown in one direction. It's the same reason why an explosion from your engine doesn't blow up the gas tank. Dung, dung, dung. The more you know. So, okay, you guys want to talk about... Here, I'll put this up here in the background. You guys want to talk about... let's talk about the F1. The F1 is a gas generator engine. So what it does... The F1 is an open cycle... Well, actually, it's a regenerative closed cycle gas generator. So about as simple as you can make a rocket engine. So with the F1, you basically have picture a jet engine in your mind. Just a jet engine on the side. So the rocket engine is right here, okay? And you have a big jet engine on the side. Now the jet engine doesn't have any intake. There's no intake, there's no spinning turbine in the front, there's no compressor. Why? You don't need a compressor because you're not sucking in oxidizer as air. It's not a jet engine. It's a gas generator. So the gas generator is like half of a turbojet, minus the turbo part. Or minus the jet part, I should say. The turbo part stays because you have a turbine. So there's basically a little rocket engine inside of this jet engine, a little combustor. And I say little, the one on the F1 is like about a meter wide almost. And basically what they do is they spray a lot of fuel and a little bit of oxidizer in there to get a very energetic explosion. That explosion happens, it gets forced through a turbine wheel, it looks almost exactly like a turbine wheel on a turbocharger on a car. Same idea. You're basically forcing that gas over that turbine and it's making it spin. All right? Now that gas goes past the turbine and gets exhausted, but we'll get back to that in a second. Now you're making shaft horsepower. You're making something spin. That turbo, all right? That turbine on this gas generator jet engine is attached to two fluid impellers, fuel pumps, hence turbo pump. Turbo pump. It is a fuel pump that is being driven by a jet engine. This is why I like rockets. That's really freaking cool, actually. So there's two fluid impellers on this axle where the compressor would be, where the part that sucks in air would be. They don't have that part. You don't need that part because you're not sucking in air because your oxidizer's on the rocket already. It's liquid oxygen. So you have two fluid impellers, and those fluid impellers are pulling the fuel from the tanks. They pull the fuel from the tanks, and they put it into that shower head thing that we were looking at. Now, if we go back and look, if we go back here, and I think I closed out. You go back here and look, there's two dots on either one of these that are really close to each other. Liquid fuel oxidizer, liquid fuel oxidizer, liquid fuel oxidizer, liquid fuel oxidizer, liquid fuel oxidizer. Think about how complicated that gets. Oh yeah, that gets pretty damn complicated real quick. Yeah, each one of these liquid fuel oxidizer, liquid fuel oxidizer. Every single one of those. Two next to each other. One's liquid fuel, the other one's oxidizer. All the way around. That's what the turbo pumps push the liquid fuel and liquid oxidizer into. They atomize in here, and they hit the explosion that's happening in here. They explode even more hot gas gets forced out of the engine. Now, if we look at an F1 engine kind of from the side here, remember I said the gas from the gas generator gets dumped overboard. Well, that's not necessarily true. Your fluid impellers are up there. Your inlets, those are your inlets from the liquid fuel in the oxidizer tank. Right? The injector plate's up here somewhere. It's inside there. And then your gas generator is right here. There's the gas generator. The gas generator exhaust goes down here through this big honking flex pipe and then gets put into the manifold. It gets put into this plenum right here. It's not really manifold, it's more plenum. It gets put into that plenum, and what that plenum does is cool the outside end of the nozzle, because the F1 engine generated a lot of heat. And remember how I said the gas generator fuel that's being delivered here is extremely fuel rich for a bigger explosion? Running fuel rich on a car, rocket engine, jet, whatever, keeps the engine cool and gives you a more energetic explosion, but it's not very efficient. But you got to remember, this is a first stage engine. Efficiency be damned. Efficiency doesn't matter if you don't have enough thrust to make it out of the grav well. That's not a good idea. Yet efficiency be damned. So this thing has a lot of colder gas coming out of it, and they circulated that gas into a manifold that film cooled the F1 engines. That's why if we go back here and we look at a picture of an F1 engine firing, there's that sooty cloud right there. And then nice explosion happens down here. That's the exhaust from the gas generator. Extremely fuel rich, unburnt RP1, so unburnt kerosene cooling this part of the nozzle. Now, okay, that's that part of the nozzle. What about the upper part? What about the other piece of the nozzle? Well, this part up here, if you noticed from those pictures that I showed you with the injector plate and whatnot, right? It looks like there's a lot of tubes here. These are just a lot of tubes. Well, rocket engines are... Long story short, it is a bunch of tubes. It's a bunch of tubes being held together by an outer belt. See these metal strips? Those metal strips hold those metal tubes in place. If you are familiar with a Wild West barrel, yeah, if you're familiar with barrels from like Western movies and from the Wild West, that's just a bunch of pieces of wood with metal strips holding them together. Literally that. Yes, that's how, that. So why? Why do you want a bunch of tubes held together? Well, on the F1 engine, they circulate liquid oxygen through those tubes. LOX goes through those tubes. This is how they made a lot of rocket engines in the 60s. They just literally took a bunch of pipe and just put them all together and then bolted that all together with these outer bands right here. Yep. The liquid oxygen from that fluid impeller actually goes down here. Well, it doesn't really go down. It starts up here, goes down, and then goes back up, and then goes in. Yep, it goes down, does a U-turn, goes back up, and then goes into the injector plate. That's how they keep the metal from melting. They take the colder propellant and they put it through the nozzle. And then they couldn't do that all the way down to here, so they use the gas generator. They use the gas generator to go all the way down. To get cooling all the way down. And you know what the crazy part is? The F1 engine still had cooling problems. After all that, still have cooling problems. This is regenerative cooling, yes. But Shimoda, I would like to add that there's two types of regenerative cooling. This is that's closed cycle regenerative cooling right there. This has closed cycle regenerative cooling and stage propellant regenerative cooling. I think it's called that. Propellant stage regenerative cooling. I think that's what it's called. Basically, they're doing two. This is what I mean about kind of being a little bit hasty in the design. Haji, you see what I'm talking about? They have many ways to cool the things, and even this wasn't enough. Even that was not enough. The F1 engine still had overheating problems. They still had overheating problems because if you go to watch a Saturn, let's go in here. Ready? Saturn V launch. Let's just look at a picture. See if we can get a picture of the engines up close. That's a render. That's a drawing, not a render. Where's all the cooling channels? You could see the manifolds from the engine, but it looks like those engines are wrapped in aluminum foil. They're literally wrapped in asbestos. They put asbestos. They wrap the engines in asbestos to get them to keep them from overheating. Now I know what you're going to say. Isn't asbestos an insulator? How's that going to keep it from overheating? Isn't that going to keep the heat in? Not necessarily. When the outside of the engine is being heated from the exhaust from the other engine right next to it, they wrapped them in asbestos. They couldn't cluster these engines together without them overheating, so their solution was just to wrap it with asbestos. And that's exactly what they did. Every Saturn V. The F1 used 50% T85. Oh, no, it uses T-tab, triethyl aluminum and triethyl borane. So, Goalie, there's no spark igniter. It's a T-tab ignition. So, pyrophoric igniter fluid. Triethyl aluminum and triethyl borane. What those basically do is that when they combine, when the TEA and the TEB combine into one, like, T-tab thingamajigger, if that finds oxygen, it's going to explode. Yeah. It's called pyrophoric ignition. Crazy, right? Another Band-Aid solution. Yeah, exactly, fireworks. See what I mean? The F1 engines barely freaking worked. They barely worked. They were good enough. Don't get me wrong. They were fine. But this is what I mean. That's what I mean when I say Apollo, even Apollo Pro, like to draw this conversation all the way back to what we were talking about in the beginning. Even the Apollo program was unbelievable. But spaceflight doesn't, even with all these Band-Aid fixes, all this risk aversion, all these ways to just get it to work. You know, when they went to screen the Apollo 13 movie to people, people didn't believe it because they called it too unrealistic. See what I'm saying? Crazy, right? Spaceflight's awesome. It doesn't need any hype. It's ridiculous in its own regard. Hey Fred, what's going on? Oh, nice, Aqualux. That's good. Hell, it helped that you only had to worry about them working once. Yeah, I'm not quite sure that these would have worked the second time. The star started with the question if NASA had a backup rescue mission. Yeah, exactly. But see, spaceflight's complicated. You can never answer it with one sentence. It's like anybody that can do that really knows their stuff. And don't get me wrong, I'm kind of good at it, but even sometimes I have to, you can't explain that with one sentence. You can't explain that with a paragraph. It has to be a freaking paper. It turns out that this stuff's complicated. Guys, and even that whole long explanation, Haji, that's the condensed version. Yeah, that's the condensed version. Fleckin, how did the liquid fuel going through those veins not flash into gas? Is that the whole chilling the engine thing? Where the engine is pre-chilled and can't just get up to temp to flash the fuel in? Yes. You thermally condition the engine. The engine has an operating temperature, just like a car engine. Car engines have operating temperatures. Rocket engines have operating temperatures. It's usually really freaking cold. Like really freaking cold. Can a rocket backfire? Yes, you saw that happen with Booster 7 a couple of months ago. Now, don't get me wrong. It doesn't backfire back into the fuel tanks, dude. That usually doesn't happen. When it does backfire, if at all, you're basically describing a hard start. What's called a hard start? Rocket engine hard starts do bad things. Here. You want to see a hard start? I'll show you a hard start. This is the closest thing that I have that I can think of off the top of my head that happens when a rocket engine backfires. So check this out. So keep in mind this footage is in extremely slow motion. Goalie, what happens here? What happens here is basically the engine is on right now. So not on. The engine is, this is the equivalent of like cranking a car over, like like that. Basically, your turbo pumps are on and they're delivering atomized fuel into your combustion chamber. They are on. You are delivering liquid methane and liquid oxygen. They are mixing and they are going out of the nozzle. That's what's happening right here. Here's what happens when it finds a source of ignition that's not inside of the rocket engine. That's atomized liquid fuel and atomized oxidizer. And it found a source of ignition. Anybody ever have science class where the professor takes like a bottle of, like they have a bottle of like alcohol or like gaseous hydrogen and they put the match over it? What happens to the bottle? The flames kind of go down and then watch. Yeah, this gets fun. Wait. There it was. Uh-oh. Blue flames, methane, and the explosion promptly goes up into the combustion chamber. It pressurizes and detonates and blows the combustion chamber off of the injector plate. Yeah, that didn't work well. That's the closest thing you're going to see to a RUD. Oh, wait, there was one more. Headphone users. I'll give you 5 seconds. Yeah. A couple of you guys in chat were saying that's what booster 7. Yeah, that's a backfire. That's why they promptly took the thing off of the test stand and sent it back to the build thing to make sure that nothing did what that first rocket engine did and blow in half. Yeah. Kind of dangerous. I said it at the time, goalie. Booster 7 doing that little pop thing was the biggest carburetor backfire in history. Anybody ever get the ignition timing wrong on an old car? You go to start it and the carburetor turns into a flamethrower? Literally that, but with rocket engines. Yep. There should have been around 7 tons of CH4 there. Yep. Does atomized fuel mean it's just really small droplets like a carburetor needle does, or is it different? So what a carburetor does and what a rocket engine does is not that far off, Haji. It's really not that far off. Atomized fuel is basically, if you take fuel and you drop the pressure, it spreads out, right? You drop the pressure and it tries to fill up that pressure and it spreads out. When it spreads out at that low pressure, it'll basically find oxygen and kind of stick to it, basically. Yeah, it gets a little sticky. If you deliver fuel at low pressure like that, like what a carburetor Venturi does, it's the same thing. Carburetor Venturis do the same exact thing. They atomize fuel with oxidizer, with air, and then you deliver that into the engine. That's what a carb does. Rocket engines do that exact same thing, only they do it with 2 liquids. Yep. And the fuel is delivered by a jet engine with a pump, with a fuel pump attached to it. Yeah. So you got to get that fuel that's at extremely high pressure to go from extremely low pressure to find a nice big explosion and then get forced out of Venturi. That's literally what a rocket engine and a carburetor, not that far off from each other. Yeah, really not that far off. A lot closer than you think. Is NASA delayed? Can I FaceTime you? No. SpaceX is actually static firing soon. Ray, text me, please. That's why rocket engines that use what's called a stage combustion cycle, like Raptor engines, for instance, that's why rocket engines that use a stage combustion cycle are more efficient. You know what they're doing? You know what a stage combustion cycle does? It atomizes one of them. Or both, the fuel and the liquid fuel and oxidizer. The shuttle engine, for instance. Fuel-rich stage combustion. It takes hydrogen and it atomizes it by turning it into gas, and then introduces it to the liquid oxygen, and then puts it in the combustion chamber. An engine like an RD-180 on Atlas V or an RD-191 on the Russian Angara rocket, those use oxidizer-rich stage combustion. They spread the oxidizer out by staging it. They basically pre-combust it a little bit and get the oxidizer to spread out, and then spray the fuel into the oxidizer, and then get the rocket, and then put it into the rocket engine, and then it blows up. It'll go right to your thighs, and then you'll blow up. Raptor is full flow. It takes the liquid methane, atomizes that, takes the liquid oxygen, atomizes that, has them meet each other, and then goes into the rocket engine. That'll give you the most efficient, and it'll give you the highest amount of thrust. Oxygen-rich stage combustion favors thrust. Fuel-rich stage combustion favors efficiency. If you combine them into one, you get the best of both worlds, which is what Raptor is. The Orion update is starting now. Oh, man. There's too much stuff going on. We'll go to the Artemis 1 update.
Hi, everyone.
Hello, how are you? I'll just go over here like this. There we go. Boom.
This one mission, now halfway into this.
Why are you like this, NASA? Why are you like this?
And how the mission is going so far. We have a panel of briefers joining us from NASA headquarters. We have NASA Administrator. And here at Johnson Space Center, I'm joined in the room by Mike Serafin, Artemis 1 Mission Manager, Rick LeBrode, Artemis 1 Flight Director, Howard Hugh, Orion Program Manager, and Vanessa Weich, Center Director at Johnson Space Center.
Fruita, there's nothing I can do about
Again,
that.
thanks for joining us. We have some media here in the room as well as on the phone. Ahead of
I'll
taking
try to
questions
balance it as
today,
best as I
just a
can.
reminder, you can press *1 to raise your hand in the phone to ask a question, and press *2 to lower your hand if your question has been answered. But before we get to those, we're going to turn it over to NASA Administrator Bill Nelson for some opening remarks.
All right.
Thank you so much.
You're
Hi,
welcome,
everybody.
Bill.
Well, the NASA
Hi,
teams
Bill.
have been very busy over this holiday weekend because of the unbelievable can-do spirit. Artemis 1 has had extraordinary success and has completed a series of history-making events. So, for example, on Friday, for the first time, a human-rated spacecraft successfully entered that orbit for Artemis 1 called the Distant Retrograde Orbit. Then on Saturday, Orion surpassed the distance record for a mission with a spacecraft designed to carry humans into deep space. And that record before had been set by Apollo 13 at about 248,000 miles from Earth. And just over an hour ago, Orion set another record, clocking its maximum distance from Earth, 270,000 miles. And of course, Artemis builds on Apollo. Not only are we going farther and coming home faster, but Artemis is paving the way to live and work in deep space in a hostile environment, to invent, to create, and ultimately to go on with humans to Mars. Now, since the launch, we have been receiving critical data back, and there's a lot more to come. For example, many of us know Arturo Campos was a NASA engineer who developed a plan to bring the crippled Apollo 13 crew home safely.
Boom, baby.
For a mission that something terribly went wrong, it's looked in the annals of NASA as one of the most successful missions because they saved the crew. Well, on the spacecraft now, Orion, is Commander Munican Campos' namesake, his namesake, aboard Orion. And this is a somewhat what we would call a mannequin, a Munican. He's outfitted with sensors to provide data on what crew members might experience in flight, and that data will continue Compost's legacy of enabling human exploration in deep space. Of course, we've said from the beginning, since this is a test flight, the biggest test after the launch is the reentry, because we want to know that that heat shield works at about 5,000 degrees Fahrenheit, almost half as hot as the sun. Coming in at 32 Mach, it's going to hit the atmosphere at about 200,000, at the ultimate entry point, and then it's going to dip down about 200,000 feet into the upper atmosphere at that 25,000 miles an hour. And then it's going to pull up and it's going to bleed off some of that speed to about Mach 22, 17,000 miles an hour. We've already learned a lot. And this team's resilience is just unbelievable. And it's incredible how smoothly the mission's gone. But it is a test. And that's what we do. We stress it and we test it. And when Orion comes home on the 11th of December, splashing down in a couple of weeks, we look forward to learning what all those sensors will have told us in order to be able to put 4 human beings on the top of Artemis 2. And then we're going to the moon, into lunar orbit in preparation for Artemis 3, where we will have 4 go into a lunar polar elliptical orbit that will then have 2 of the astronauts in the lander go down to the surface. That will be the first woman and the next man. So let me turn it over to Vanessa Weish. Vanessa is our great director out there at the Johnson Space Center. Hey, Vanessa, take it away.
Okay, well, thank you, Administrator Nelson. And I believe we have a video that we're going to play, so we're going to play that video first.
Carter, long story short, no, this isn't for mining helium-3, even though you could. NASA's exploring.
And liftoff of Artemis 1.
Boosters in ignition.
We rise together, back to the moon and beyond.
Oh, yeah. NASA can't mix audio. Oh. It's freaking awesome, dude. Look at that. It's pretty good.
Wow. So
Wow.
Go Orion. You know, this mission is just the success of many women and men from all across NASA. And then for Orion itself, Lockheed Martin and the flight control team. It's just a wonderful opportunity that I have. I've gone over to the control center
Very festive,
and had an opportunity to talk with many of the members of the flight control team, people in the support rooms, back rooms, and thank them for their work. But now isn't a chance for me to publicly say thank you to each of them for all of the hard work that they've put into this
DROs
mission.
on the center screen.
I also want to thank Howard Hugh as the program manager. I want to thank Rick LeBrode as the lead flight director, and I want to thank Mike Serafin as the mission manager. The mission is just going completely flawless. Of course, we're learning. There's things that we have to, figure out about the systems themselves.
Always is.
But, Orion is just performing so very well. This is a chance for us
You
to
don't have to,
talk
Sam.
about the fact that with
off the
Orion
moon.
today, being a spacecraft that is in lunar orbit, we also have a spacecraft, the International Space Station, that's in Leo. So right now, our teams are controlling 2 spacecraft. And it's just amazing, the accomplishments that we've had, and many more to come. But with the Artemis program, as the administrator said, right here at NASA's Johnson Space Center, we're just super proud of the Orion. We're also working on the Gateway, which will be a platform in the lunar vicinity. We're building new suits. We're building rovers. We're working with the Marshall Space Flight Center on the lander. All of that so that we can continue to explore with our astronauts going into space. This mission is just a great success. It's the beginning. It will allow us to do Artemis 2, where we will put our astronauts on board. The tests that are going on today, you're going to hear the mission management team, because Orion is performing so well, they are adding new test objectives to the mission. So that's a great thing. That lets you know that right now we're learning about this vehicle and preparing for going forward into the future. I did also just want to share that, right now we have spent this past weekend celebrating Thanksgiving, and our flight control teams did get an opportunity to celebrate Thanksgiving. And we just want to say again, thank you to all of the people that are making this possible. It takes many, many people all around the world to make this happen. And with that, I just want to say thank you to each and every one of you. You're doing a great job, gentlemen.
Thank you, Vanessa. And for additional opening remarks, we'll turn it over to Artemis Mission Manager Mike Serafin.
Well, good afternoon, and thank you for those kind words, Administrator Nelson and Vanessa. Welcome to Flight Day 13 of our 26-day marathon. As Vanessa mentioned, we are looking at adding additional objectives, and the halfway point in this mission allows us and affords us an opportunity to step back and look at what our margins are and where we could be a little smarter to buy down risk and understand the spacecraft's performance for crewed flight on the very next mission. So this halfway point teaches us to number our days so that we can get a heart of wisdom. And adding 7 new objectives above the baseline that we agreed on to further characterize the thermal environment, but also the propulsion system, allows us to again get smarter for crewed flight. In terms of mission status, we are continuing to proceed along the nominal mission, and we passed the halfway point in terms of distance from Earth. We passed the halfway point in terms of time in the mission plan. And in terms of mission objectives, if you look back at Priority 1, which is demonstrate the vehicle at lunar reentry conditions, we bought down half of that on launch day by the rocket delivering us, the Space Launch System rocket delivering us to the point of translunar injection and setting up the initial conditions. We will not realize the second half of Priority 1 until entry, descent, and landing day, as Administrator Nelson described in his opening comments. In terms of priorities 2 and 4, we are 25% complete, so we've got 31 of the 124 baseline objectives complete. We have 37.5% of those objectives in progress, or 46 of the 124, and then 37.5% yet to be started. A lot of those are essentially tied to entry, descent, landing in the post-splashdown time frame. So adding the 7, what we're calling real-time objectives, adds above and beyond that 124 objective content in terms of priorities 2 and 4. And then priority 3, retrieving the spacecraft. We will again achieve that on entry and splashdown and recovery day. We are starting our initial preparations for deployment of the recovery forces out at Naval Base San Diego. Our Exploration Ground Systems-led recovery operations team in the U.S. Navy have begun their preparations for what they call just-in-time training, and they are going to deploy tomorrow for that training, and then come back to shore and then set up for recovery. In terms of the mission management team,
Just in time.
we did meet, since the last time I was here to talk to you, we did meet on Tuesday, November the 22nd. It was a non-decisional meeting, 45 minutes, and we just largely statused the progress of the mission. We also met on Wednesday, November the 23rd. Again, that was largely a non-decisional meeting. We did go through the imagery findings to date, and we did discuss those, and there were no imagery findings of consequence through our integrated imagery team. And then the mission management team was off Thursday, November the 24th through Sunday, the 27th, largely because the mission is proceeding so well. And none of the anomalies or funnies that are out there are of consequence. We did meet today for 2 hours. It was a decisional meeting. We did close one of our anomaly resolution teams associated with the star trackers and the random access memory built-in test hardware that we're seeing a number of funnies on, and we essentially concluded that the hardware is performing as expected, and this is really just a byproduct of the flight environment. And then we did approve 2 flight rule waivers associated with setting up for the additional flight test objectives, and those will enable us to set up the initial conditions for that. So with that, I'll pass it back to you, Leah.
Thanks, Mike. And I will pass it over to Rick LeBrode, Artemis 1 Flight Director.
All right, thank you very much. I can't tell you what a pleasure it is to be here to give you a status on how well things are going. It's always a lot easier when things are going so well. I think I want to start with I have a graphic that shows, that you've seen before. It's the mission trajectory. So if you could put that up, please. It's pretty straightforward. We're halfway in the mission, so you figure we're halfway through the DRO. So I don't know if we got that. Okay. There we go. And if you look at number 11, which is essentially, like I said, halfway into the DRO, that's where Orion's located right now. The imagery was crazy. You saw that the imagery and that opening videos clip, and I can tell you, I was in the control center at the console for a majority of those images, the ones that include the Earth and the Moon, and it's really hard to articulate what the feeling is. It's just amazing to be here and seeing that. So it's certainly a pleasure. So I'll just give you kind of a status on where we are. Mike talked a little bit about, we're just clicking off our detailed flight test objectives. Everything's going extremely well. Going so well that we're working with Howard and his team, the engineering team, and the European partners to add more test objectives. If you recall, if you supported the pre-mission briefing, I talked about, the simple question was, why are we flying the flight, or what do we want to try and accomplish? And up to this mission, everything was just test data. So a lot of our models that the engineering team uses for their analysis, they're using just data, figures and test information. Well, the effort that we're doing now to get this real-time performance data from the vehicle and the environment is that valuable data that's going to be put into the test, to update the models to allow us to know exactly how this vehicle is going to operate, and it'll relieve us of a lot of our constraints. A lot of these objectives are going to be, the thermal environment. Try to expand the thermal environment. Right now we're constrained to, we can get out of the tail to sun attitude for upwards of 3 hours, but when we come back, we have to wait 10 hours before we can do another excursion. So we're hoping to get more information, get smarter on how the vehicle thermally responds, to give us more flexibility, and that'll be directly beneficial to the future Artemis missions when we're flying the crew. Let's see, for the mission to complete the trajectory, we had planned for 19 translational burns. Up to this point, we've done 9, and we've used every one of Orion's propulsion systems. We've done 3 larger burns greater than 100 feet per second using the orbital maneuvering system, the OMS engine. We've done 3 using the plus X, or you'll hear them called as auxiliary thrusters. And those 3 were on the order of less than 9 feet per second. And then we did 3 also using the reaction control system, RCS system, and those were all less than 1 foot per second. And we did 2 of those burns where we actually maneuvered into attitude, the specific attitude, and thrust in a specific direction. And the last one we did was, it was a very small burn, but we did it multi-axis, where you don't even have to maneuver to the attitude. So it was a great test of Orion propulsion capabilities. We were going to do a burn today. We call these orbit maintenance burns, but it was a very small burn. We opted not to do it, and a part of the reason also is because when we do our next orbit maintenance number 3, which is in a couple days, we want to. This is one of those test objectives that we're adding, and that's we want to burn the plus X. The auxiliary thrusters for 100 seconds. A lot of that's going to be testing the thrusters themselves. They're rated for much longer than that, but we haven't used it yet for those kind of durations. So we're going to do that. But we're also going to test. I think we want to test some of the pluming on the solar arrays during that time frame as well. So let's see. The upcoming. Just to give you a little highlight on what's coming up. We'll depart the distant retrograde orbit on Thursday, start heading back towards the moon, and then when we have the return powered flyby, that'll be on flight day 20, and that again when we fly by the moon, will be 80 miles off the surface. So we should expect to get some more spectacular imagery of the moon as we fly by. So I think that's all I have to report at this point. So I'll hand it back to you. Yeah.
Thanks, Rick. All good things. And I will turn it over to Howard Hugh, Orion Program Manager.
Thanks, Leah. Let's see. I'll start with thanking Administrator Nelson and Senator Director Weish for recognizing the team. Certainly, it's very tough working during the holiday and missing some time with the family and friends, but the team performed tremendously. I want to thank the flight control team, our engineering team, and our European partners, our Lockheed contractors, who worked tirelessly to make these burns happen and monitor spacecraft as we get into this distant retrograde orbit. It was really an important phase of our mission. It got us into a point where I feel really good getting to this part of the mission, and a really opportunity to, I would say, catch our breath a little bit and do a very important orbit around the moon, and being able to do some tests and demonstration of additional capabilities for the spacecraft. Of course, you've heard from Mike and Rick that the spacecraft is operating just tremendously well so far, and we're really happy with its performance overall across all the subsystem areas. And we've been able to accomplish other what we call detailed flight test objectives as well as we've gone along the mission, and we're going to try to accomplish some more in this DRO orbit. And I think it's a testament to not only the spacecraft capabilities and the performance so far of the spacecraft, but also the team. The team has been doing a great job of not only monitoring our spacecraft and looking at some of the funnies and making sure it's performing as expected, but also looking at opportunities to further along test this very important mission and the spacecraft that we have to further future missions and buy down future risks as we put crew on board. And I think that's a great opportunity that we have today in the DRO. I would say that also, I mentioned last time we were here, our performance across the board continues to be outstanding relative to power we're generating, continue to generate 20% more power than we really need. We still have tremendous amount of propulsive capability or reserves in the prop tanks, and we certainly are looking at other performance measurements across the board, across the spacecraft, and those are all going very well. So really happy where we are halfway through the mission. Looking forward to completing this part of the phase and getting our spacecraft home safely. So thank you, Leo.
Thank you, Howard, and thank you again to all of our briefers who have joined today. We will now move into the question and answer portion of our session. So a reminder, if you're online, please use the *1 to raise your hand if you have a question to ask, and *2 if your question has been answered. We will start here in the room.
Thank you, Mark Carreau with Aviation Week and Space Technology. I know I'm leaning forward a little bit, but I'm wondering if you've received enough significant data from this mission so far that you can maybe update your planning dates for Artemis 2 and 3, even, an estimate or a season or a month or a year? Or...
Do you want me to start with that one, Howard? And you can.
Yeah, and I'll follow.
Okay.
That'd be great.
Yeah, thank you for the question, Mark. We are starting to look at the Artemis 2 dates. We know that we need to refly some of the components from the Artemis 1 vehicle on the Artemis 2 vehicle, and we're looking at the detailed schedules there. It's a little bit early to say exactly what those are, but we did talk today in the mission management team about how the avionics boxes are performing that we plan to refly, and they are performing very well. I don't know, Howard, if you have anything to add on that.
Yeah, I would say that to add on what Mike's saying, I think it's really good that we're looking at and getting all this data, especially with the avionics boxes we need for Artemis 2 from Artemis 1. So we'll be making sure those get off the vehicle when we splash down safely and get the Artemis 1 crew module back. That will go into our Artemis 2 spacecraft. For Artemis 2, we're also right now in the flow, so we're working very hard to go as fast as we can. And we're learning a lot from our obvious Artemis 1 flow, and we'll incorporate those lessons learned into our Artemis 2. We still have a lot of testing ahead with Artemis 2 spacecraft, both the crew module and the service module that we need to accomplish. And I think after this mission, as the boxes come back from Artemis 1 and put on board Artemis 2, at the agency level, we'll be reviewing all our schedules across the board and stitching those together. So that's where we stand today.
Yeah, and Mark, the only other point that I would add is, if you come back to our priority 3 objective, which is retrieve the spacecraft for programmatic cost savings and avionics reuse, that is baked into that retrieve the spacecraft objective. We had to work our way through a number of challenges just to get to launch, and we had a variable mission duration, and we couldn't anchor the schedule activities until we got through the hydrogen leak challenges that we had, and the hurricane, and a whole host of other things, and then the launch date anchored which class of mission we were flying, and we are on a short class mission, a 26-day mission. So we're taking that into consideration now, and we're starting to work that into our schedules.
Thank you. And just before we go to additional questions, a couple of things I wanted to note. Administrator Nelson and Center Director Vanessa Weich won't be able to join us for the question and answer portion. And then just a reminder to our media to please state your name and affiliation and to whom your question is addressed. So with that, back to the room.
Thanks very much. Eric Berger with Ars Technica. 2 questions. First of all, for Mike, I think you talked about priority 1 objectives, and I'm just curious how much of the overall risk at this point you've retired. You've gone through launch, obviously. MMOD is looking pretty good, or it was as of the last briefing. The 3 different classes of thrusters on Orion seem to be performing pretty well. So, landing is kind of the main objective left. So is that 50% of the risk, 75, 25? Just trying to get a sense of where your primary concerns are in terms of sort of overall risk retired. And Howard, there was a blog post about a loss of comms several days ago with Orion. I'm just wondering what the resolution of that issue was, and if that's something to be concerned about going forward.
Okay, I'll start, Howard, and you want to follow up on the blog post?
Yeah.
Okay. So again, thank you for the question, Eric. In terms of risk that's retired, we did talk pre-flight about the Pareto chart, which identifies our top risk drivers. Certainly, micrometeoroid and orbital debris, which is our top risk driver, is in play until we get out of the space environment. But being halfway through the mission puts us roughly halfway through that risk, because it is a function or a byproduct of how long we're in the spaceflight environment. We had other risks associated with first-time flight of the rocket and the overall system performance of the rocket, the integrated avionics and software risk, and RS-25 engine. All of those have been retired. We have a demonstrated rocket. In terms of the spacecraft, some of those have been bought down, but some of them are not going to be retired from a mission standpoint until we get to landing day, specifically the parachute and parachute deploy system, and then the heat shield. So that, again, comes back to our priority 1 objective. The rest of the risk drivers that come to mind, we certainly have done a much better job of characterizing the overall system performance, and I think we are buying down some of that. So that's kind of a, if you're looking at our top 10 risk drivers, some of them have been retired, some of them are still in play, and some of them won't be realized for good or bad until we get to entry, descent, and splashdown day. And I'll turn it over to Howard for the blog question.
Yeah, Eric, I'm not sure specifically which comm outage you're referring to, but I'm going to ask Rick to talk about, we've had some ground comm issues, not on board, but I'll let Rick go first.
Yeah, so if it's the one I believe you're thinking about, in order to make sure we get enable comm from the vehicle, flight controller and mission control Inco has to send a command to get the onboard comm system configured, and then the ground controller, also flight control position and mission control, coordinates with the Deep Space Network engineers, gives them what the configuration of the vehicle is going to be. Then they actually load the parameters to configure their network to support it. So it's complex. And we've changed things since the beginning of the mission is to give us more capability, open the bandwidth. So we've added 2 more modes. They're based on data rates, and then we go uncoded, which then doubles our bandwidth. So we're not using a coding scheme to improve our signal-to-noise ratio, which allows us to actually bring down more data. Do that streaming. When we started streaming the video, it was because we were able to open the bandwidth, which allows us to do file transfers, bring the data off the vehicle, and then also do the streaming video. Well, it was simply a misconfiguration at the Deep Space Network, where they were set up for a data rate that the vehicle was not set up for, and it just going through the troubleshooting process, finally figured that out, and then we recovered. Once we got the right data rate, we recovered the return link.
Yeah, and Eric, just to add a little clarity on this one, as I understand it, Rick, and you can correct me if I'm wrong, we need the spacecraft data rate, the Deep Space Network ground site data rate, and the MCC data rate all to be in the same configuration, and we got out of configuration with those just due to kind of some ground-to-ground coordination. Did I get that right?
That's exactly right.
Okay.
Okay. Next question is on the phone with Marcia Dunn.
Hi, good evening. A couple of questions, probably for Mike or Howard. How many avionics boxes are you going to be taking from Artemis 1 from this Orion put on the next one? And what else is being shared that will be removed from the spacecraft for the next mission, no matter how small or insignificant it might seem? And then secondly, for Splashdown Day, how many people and craft do you expect to be part of the recovery effort? How many people and how many ships, planes, helicopters? I'm just looking for a big picture. Thanks.
Yeah, maybe Mike, I'll take the first one, if you can take the second one. Mm-hmm. Yeah, Marcia, thanks for the question. Right now, we're looking at 8 avionics boxes across the board from Artemis 1 to bring from the Artemis 1 spacecraft and Artemis 2. Let's see, I think your other question, and maybe you can repeat the second half of your question if I don't get it exactly right, has to do with, can you repeat that one more time? You wanted additional information on what else is, I think, what else we're bringing forward that's not avionics boxes, is that correct?
That's correct. What other pieces are you going to be pulling out for Artemis 2?
Yeah, we are. I think Administrator Nelson mentioned Munich and Campos. Munich and Campos sits on Orion seat. And so we will be using that seat for Artemis 2 as well. That's a non-avionics system that we would be utilizing on Artemis 2, but nothing else from the spacecraft on Artemis 1 that we would be reusing besides those items I mentioned.
And Marcia, thank you for the question on the recovery operation. And our recovery operations lead, Melissa Jones, is not on this call, so you might want to confirm some of this with her at a later time. But the ship, we have a well-deck ship that is provided via partnership with the U.S. Navy on Naval Base San Diego. We will put about 85 NASA and industry partner personnel on the ship to support that operation, and that is above and beyond the ship's standard complement, which is a couple of hundred sailors. We will have deployed from the recovery ship itself at least 4 small boats, what they call small boats. 2 of those will be what they call rigid hull inflatable boats, and then 2 of those will be kind of smaller rafts. And then we'll have 2 helicopters deployed from the flight deck, one to support some of the imagery observations associated with the parachute deploy and splashdown, and another one to support locating the objects that are jettisoned from the spacecraft as it descends, things like the forward bay cover and some of the parachutes as part of the parachute deployment sequence. And then we'll have at least 1 aircraft at a higher altitude capturing imagery. So that's kind of a broad picture of it. We can get you more details at a later time.
Okay, next up we have David Curley with Discovery Channel. And David, if you're speaking.
Sorry about that. I was having a little trouble. Can you hear me now?
Loud and clear.
I guess this is for Howard. Quick question. What kind of data are you getting from inside the capsule in the environment the astronauts would be in? Specifically, are the temperatures right? What are you seeing so far inside?
Yeah, right now, good question. Right now, we are getting temperature readings. We're getting, obviously, pressure readings as well inside the cabin, and everything's nominal as we expected. Certainly, what was loaded or what was in the atmosphere when we closed the hatch is what we've got, and our leakage rates are really low. I think it's like 0.03 per day or something like that, PSI per day. So we're really understanding not only just what's inside the cabin, but obviously a lot of measurements we have inside the cabin relative to Munich and Campos. The radiation sensors are all being recorded, so we won't get that data from the cabin until we get back on the ground.
Next question is from Bill Harwood.
Hey, thanks. I got 2 quick ones, one for Mike and one for Howard, I think. Is the Star Tracker issue you've mentioned a couple of times, is that the most significant problem you've had with Orion? Or is there anything else that's provide worry, or maybe not worry, but required a similar level of troubleshooting? And I wasn't clear how you resolved that, or if you just decided that's just the way they operate and we understand how it works now and that makes it okay, or if there's something you had to do about that. And Howard, can you tell us what those 8 boxes are? I know it's probably buried in the press kit somewhere, but I can't remember what the avionics boxes are that you're going to take off Artemis 1 and put on Artemis 2. Thanks.
Okay. Yeah, hey, Mike, let me, maybe I'll address both questions, if you don't mind, and you can add to it. I think with the Star Tracker, it's certainly the highest visibility. When we first, we had a couple issues where we took, I think, a radiation hit on the on the Star Tracker itself, and we also had this issue with a bit flip relative RAM where inside the box itself, it has error detection correction automatically. And I think I mentioned in the last press conference, it does when you have a radiation hit, it may flip a bit in the memory, it auto corrects itself, and it just tells you. And it's a very, very good system that is on a lot of deep space kinds of hardware, avionics hardware. And in this case, when it first tripped, we were getting indications that Star Tracker wasn't performing. And I think through our analysis and, of course, very detailed look at all the data that we got at that time, we made some decisions, obviously, to press forward. But it turned out that the Star Tracker was working just beautifully. It was outputting navigation data as expected. This bit trip, we found out through our our last few days, several days of hard work by the team, is that this is very anomalous behavior. Many of the star trackers in deep space and even in geosynchronous satellites and low Earth orbit satellites have data that shows that they take these kinds of RAM upsets, and so they get auto-corrected and they log it. And so today, when we went to the MMT, we walked through all the data. We showed a lot of detailed in terms of not only from our own program, but from other programs that the Europeans have flown, from other programs that we know about from our sister programs, to learn what they've seen, and the data corroborates what we hypothesized to be. And I think that turned out really well in terms of the Star Tracker performance and understanding what happened with the Star Tracker. So I'll pause there, see if Mike wants to add anything to that before I answer the next question.
Yeah, Bill, thank you for the question. Howard said it well. The team did a very thorough analysis of the Star Tracker random access memory bits that were being set. And this is a case where leveraging our industrial base and other missions out there, whether they're NASA missions or other missions that use this common set of avionics or very similar design to it, is helping us, and we tap that expertise. In terms of other issues that are out there, we do have one active anomaly resolution team associated with the power conditioning and distribution unit on something called the latching current limiter. It is apparently being uncommanded open, so for some reason these latching current limiters on umbilical 1, uniquely on umbilical 1, there have been a number of occurrences that are being nobody's on the ground commanding these things open. So we're trying to characterize that and understand what the hardware is telling us, and that active anomaly resolution team is working in the background. It is not a high-level concern because we have appropriate levels of redundancy. There's 4 solar array wings, 2 of these per channel, per power channel, and we're recovering from these. We just don't quite understand what the hardware is telling us, and we're expecting an outbrief from that anomaly resolution team in the next couple of days. The other things that are out there, we've talked previously about the coolant loop 1 flow rate being erratic. We believe that there's gas in the fluid, and we're periodically seeing the flow rate drop, and then it comes back up as the gas bubble moves its way through the coolant loop. We also had what I would argue was a gift handed to us from the flight environment. We had the flight control module number 1 had a reset. And that was due to a radiation hit, and it did exactly what it was designed to do. And we have a feature called a cross-channel reset, and the system recovered by itself, and it handled the radiation hit as it was designed. So we're again characterizing the system performance. We're learning from it. We're learning what the hardware is telling us. Some of this is unfamiliar to us in the flight environment, and we're rolling that into all the operations. So I don't know, Rick, if you have anything to add to that.
No, you've covered it well. That cross-channel restart essentially is when a computer goes down and comes back up, it gathers information from the other computers to basically get right back to where it was and get back into a sync with all the other 3 computers. Work just as it's designed.
And I'll answer the last question, or the second question. So we're returning the Orion IMUs, or inertial measuring units, the GPSRs, which is the receivers for GPS, and then the phase array antennas. So that's the list of items that we are using from Artemis 1 and putting on board Artemis 2.
All right, thank you all. The next question comes from Isam Ahmed.
Thanks for doing this. For Mike Sarpin, will we see the Apollo landing sites on the next lunar flyby, and which ones? Thank you.
Yeah, thank you for the question, Hassan. Rick's probably better in tune with that one, but as I understand it, we will get to see multiple Apollo landing sites.
Yeah,
Rick,
we do believe there's a team that's actually actively making the plan, putting the plan together to support the imagery as we fly by the moon. The positive is on the return powered flyby, that area will be lit, so we have the opportunity. We just got to get the vehicle in the right orientation and get the cameras going. We're going to be taking imagery, so and I don't know exactly which sites, but I know on the outbound powered flyby there was 4 sites that were all in the dark, so we didn't capture them. But my expectation is the same 4 will be available this time with the proper lighting conditions.
We're looking forward to it. Up next on the phone, we have Tim Fernholz.
Hello, everyone. Thank you for taking this question. 2 things I was wondering. One, can you talk a little bit more about the 2 flight rule waivers you need to do for the additional objectives and what that looks like? And then second, just thinking about the Deep Space Network, now that you're using it with Artemis and sort of breaking in those procedures, are there thoughts about what might be necessary to improve or invest in or add to the DSN system ahead of crewed flight with Artemis? Thank you.
Yeah, Tim, thank you for the question. I'll talk about the flight rule waivers here up front. But in terms of the accomplishing what we're calling characterizing the thermal envelope, Orion is, by design, it wants to fly tail to sun. That is for thermal stability of the vehicle, but also from a power production standpoint. And the vehicle, through analysis, is allowed to go up to 20 degrees in either pitch or yaw out of that perfect tail to sun orientation. So what we're doing is we're characterizing the corners of the box, 20 degrees, 20 degrees, and doing that. And there's also a thermal recovery time required, as Rick had mentioned earlier, about if we're out of attitude greater than that 20 degrees for more than 3 hours, we have to do a 10-hour tail to sun thermal recovery period before we're allowed to use the orbital maneuvering system. So the waiver was specific to the thermal analysis requirements and the desire to gather some of the data on that thermal envelope expansion, and that is consistent with a test flight. We want to do envelope expansion and validate our models. I don't know, Rick, if you have anything to add on the flight rule waivers.
No, you covered it.
Okay.
Well, that was for the first one. I think the second one, you're going to cover that one?
I'm trying to remember.
The second one was for the solar array positioning constraints,
yes.
Right? We for the various burns that we do with Orion, we have specific attitudes or positioning that we put the solar array wings, and that's to prevent damage from plume impingement from the reaction control thrusters. And for this 100-second plus X test, we want to put the position of the arrays different than what had been previously analyzed and was considered approved, and that's why we're waiving. And this is to gain the data that we want. That's specifically why we're doing the test. So that's the rationale for that waiver.
Yeah, and thank you for the reminder. So that the specific constraint that we're trying to avoid is not a plume impingement or a load constraint on the solar array wing. It has to do with the radiant heating from the engine that's in proximity to the solar array wing. So those were the 2 waivers that were approved, and they are specific to these test conditions and specific to the objectives that were set up. These are not just what I'll call generic waivers for operations across the mission, and we did make that clear today.
Hey, Mike, would you mind? I'll jump in with a couple fine points relative to that. From a spacecraft perspective, Mike talks about the 20-20-20 degree envelope. I mean, we've already analyzed this as pre-mission. We know that we can operate in these regimes. There were some flight rule constraints relative to the two pieces, the OMZ or the main engine, and then also the star tracker was also. So I think from an overall risk perspective, that's why we talked about, pressing forward with this particular objective, is because we feel like through our pre-mission analysis that we're able to operate in those boundaries. We just want to make sure in this real flight environment that we get to those corners of the boxes. So that's one piece, and that's the same for the arrays. The arrays, we've tested and certified them to be in these configurations, although we didn't nominally want to operate them in that because of what we need to do for the mission. But now as we do the flight test objectives, there's no risk with the hardware in terms of where we want to park these arrays for this test. So I just want to make sure that was clear, Mike.
Yeah, thank you for that, Howard. And then Tim, you had a second part to your question. I'm forgetting the second part.
No worries. Thank you for the detailed explanation. I was just asking about, given sort of the work through of the process with the Deep Space Network, is there any thought to investing in, further capabilities or improving that network ahead of crewed flight when it may be more important to get that communications done quickly?
They already did.
Yes, Tim. The answer is yes. We are very mindful that the Deep Space Network has many customers, and Artemis is one of those. But there are many science missions out there. There are many space technology missions and other partnership missions out there. So as we expand the portfolio of Artemis capabilities, whether it's Gateway or the Human Landing System, and some of the surface operations and surface systems, as we get further into the manifest, we are acutely aware that we need to improve the communications and tracking and navigation assets out there. So we do have additional investments planned in the Deep Space Network. I don't want to get ahead of that because there's probably a procurement that's in play ahead of us on that.
Okay, next question is from Kristen Fisher with CNN.
Hi, everyone. This question is for Senator Nelson, if he's still on. If not, I guess, Mike, it might be for you, but given the fact that this mission, Artemis 1, is going so well, wondering if we could get an update on when a crew may be announced for Artemis 2. Thank you.
Yeah, hi, Kristen. Thank you for the question. We've purposefully deferred that decision until after Artemis 1 is successfully complete. We want to get through a demonstration of our human transportation system before we name a crew for a number of reasons. One is just time between missions. We need to understand the time between Artemis 1 and 2. It is possible to be in training too long. And we need to find the sweet spot relative to the training time for the crew. But once a crew is named, they're going to be highly sought after people, and there are other responsibilities for astronauts in the astronaut office, and we need to keep that in mind as well from a workload and just kind of an overall flight crew availability standpoint, and their time is precious, so we've purposely deferred that until after Artemis 1. I don't have a specific date for you, but it will be after the mission.
Thank you. And our next question is from Jem Siegel.
Hi, everybody. Thank you for taking my question today. What will be the approximate length of the Artemis 2 mission? And secondly, roughly how many NASA and partner people are involved in monitoring Artemis 1? Thank you.
Okay. I'll take the mission length, Rick, and you want to take the team, and Howard, you want to talk about the size of your teams? Jim, in terms of the mission length for Artemis 2, we're looking at a 10.5-day crewed flight test. So 4 astronauts will fly a 1-day highly elliptical orbit to basically shake down the life support system and perform a proximity operations demonstration with the upper stage before it is separated at a far distance from Orion. And then at the end of that 1-day high Earth orbit, Orion will essentially perform a mission completion maneuver and use the service module to perform the translunar injection maneuver and put itself on a free return trajectory about 4.5 days out and about 4.5 days back. So it'll be a little over 10 days, and that's our Artemis 2 plan. So, Rick, do you want to talk about your team, and Howard, do you want to talk about your teams as well?
Sure. So it's a little hard, but in the front room we have 10 flight controllers, and then for each one of those they have either one, some have up to two or two support personnel in the multi-purpose support room, and then we have 3 shifts. So there you're looking at on the for the flight control team specific, we're looking at on the order of 60. That doesn't include, the ground controller who has responsibilities for making sure the facilities are configured properly. There's quite a few of those people, and I couldn't give you a number, but I'm guessing probably another 5, so 15. So we're looking around 75 people inside MCC. It's a pretty close number. And then let Howard talk to the mission evaluation room.
Yeah, that's a good question, but a tough question. I think same with Rick. I would estimate maybe 10 consoles in the mission evaluation room, which is the support from an engineering perspective. Probably a couple people on console per 3 shifts across a day. And so you're looking at maybe 60-ish people. And then we've got some support from Europe as well. They've got some people supporting from an engineering perspective. We've also got people at the Lockheed Martin facility in Denver. So probably, somewhere in that 70 to 100, somewhere around there, depending on the day and the burn. We probably bring more engineering support as needed for the bigger burns. And then, of course, as we have issues, we'll bring more people to look at these issues and try to resolve them quickly. So it varies depending on the day. But somewhere around there, probably similar to what Rick's got across the board.
Yeah, and then Jim, from the mission management team standpoint, for day of launch, because we had the propulsive elements associated with the Space Launch System, we had 24 mission management team members. We've collapsed that down since then to about 14 because the rocket has largely done its job, but we do include the Space Launch System program management team in that. And then on day of launch, the SLS Engineering Support Center out of Huntsville, which is their technical reach back, had roughly 110 people supporting, and that team has largely been sunset since we've gotten through the point of translunar injection.
Okay, we have time for just a couple of more questions. This one is from Elisha Sowers.
Hi, thank you for taking my question. This also would have been for Administrator Nelson. I know Kristen sort of asked along the same lines of what I'm going to ask, but at the top of the call, Mr. Nelson had said that the astronauts in the Artemis 3 lander will be, quote, the first woman and the next man, end quote, on the moon. And I may be way overanalyzing this, but is that slight departure in his phrasing significant? Because before now it seemed possible that there could be 2 women astronauts landing on the moon. And I'm just wondering if he misspoke, or is that comment an indication that decisions have been made? Because I know you said that the crew hasn't been announced publicly yet, but have they been decided already internally?
Yeah. Elisha, thank you for the question. I'm not going to get ahead of that one. We'll just have to wait and see what the decision is and who is on that crew.
Okay, and our last question for this afternoon is from Robert Perlman.
Hi, thanks. A question and a quick follow-up to a previous question, I think both for Rick. There was mention recently in NASA's update about Callisto being fired up, and we saw a video of, I guess, the disco or party mode. But I was wondering from a mission control perspective, as you've seen it being used, how effective of a tool is it to have the ability to query an AI aboard an uncrewed spacecraft, looking ahead to the day that maybe all 4 Orion astronauts go down to the surface and not just 2. And then just as a quick update, when you were mentioning the Apollo sites, can you just clarify in terms of the resolution that the public should expect? That are you going to be able to resolve features at the landing sites, or are you just photographing Tranquility Base or Frau Mora, and it's just the general area? Thanks.
Sure. With respect to the CIT, the Crew Interface Technology payload, I personally think it'll be very advantageous for the crews, probably more so when we actually leave Gateway and start going deeper into space, where the time delay between us and the ground and the crew, it's going to be problematic for us to be able to do things real time. And if they have a device on board that can answer a lot of their questions based on a database that they have, that seems like something that would be beneficial to the crew. As far as the way it's set up for Artemis 1, the flight control team, really, we're just activating the equipment and scheduling the services at the Deep Space Network. We got to schedule a specific antenna and then make sure it's configured properly to support the event. But as far as of all the other stuff that's going on, we're just kind of enjoying the imagery just like you guys are, but not really actively participating. I know Howard probably can give you a little bit of insight because he's participating in a couple of the events, so he can give you his perspective. I'll pause a second and see if you want to add anything there.
Yeah, I think part of this is a demonstration of the technology and really operating in the environment of where we want to be in terms of lunar orbit. And so I think we're getting really good, results. And I think it's been a good collection of data so far. And the engagement has, I think, gone very well, and appreciate Rick and the flight control team helping make that possible. I think it takes some effort to do the scheduling and coordination, and I think everybody that's participated in it has seen the value, as Rick has alluded to. And I think as time will tell, in terms of what is needed, I think the demands of what the crew requires to support and operate the spacecraft and execute the mission will determine the capabilities we need. And I think these are all good things that we're planting the seeds for and allowing us to reap those when it's time.
And as far as your second question, as far as what the expectations are for the quality of the imagery of the lunar or the Apollo sites as we fly by, there's a team working it. So I don't really have a good answer for you, but I will tell you that just the imagery that you saw of the moon surface as we went by, some of that was from our optical navigation camera. We used the solar array wings that have the cameras at the end. We're not really going to be tracking specific ground sites as we fly over. That's would be asking a bit, and you run the risk of not getting anything if you try to over-engineer it. So it'll be comparable to what you saw as we went by for the outbound powered flyby. So I apologize, but I can't give you better information than that.
All right. Thank you all who tuned in and asked questions, and thank you also to our briefers today, as well as Administrator Nelson and NASA Center Director Vanessa White here at the Johnson Space Center. A quick look ahead at some things we have coming up. We have the distant retrograde departure burn coming up this Thursday, December 1st, but ahead of that, we're going to preview with another briefing on Wednesday at 4 p.m. Central Time. Don't forget, you can also watch live views from Orion almost any time that we have signal from the spacecraft at go.nasa.gov/Artemis Live. Some amazing views that we've had so far today, so make sure to tune in and see those. You can also read our daily blog updates at nasa.gov or at blogs.nasa.gov/Artemis. And of course, don't forget, you can see the latest imagery and videos on our Flickr account at flickr.com/photos/NASA2Explore. That'll wrap it up for us here today at Johnson Space Center. Thank you all for tuning in, and we'll see you again soon.
Leah did the sign off that she does from Mission Control. That's funny. Wow. Yeah. Guys, that's pretty awesome. Yeah, dudes, look at that. That shot doesn't suck. You had some faces about the Artemis 2 mission profile. The RPOD operations, Tan, I forgot about those. The rendezvous proximity operations, they said RPOD, rendezvous, proximity, and docking. There's no docking that's going to happen. But if I'm understanding that correctly, if they're going to do RPOD, similar to the Apollo program, that means they're going to maneuver Orion around with the ICPS attached to it with the RCS. That should give us some really, really, really nice pictures of the core stage, if I'm understanding that right. Yeah. Artemis 2 is going to free return, Squish. It's Apollo 8. Yeah, it's an Apollo 8 style mission. Quick question. I'm building a race motorcycle. I was wondering if y'all think it would be better for me to learn to tune the bike or take it to a pro tuner. Take it to somebody that knows what they're doing, dude. Partial translunar injection with the ICPS. Detach and perform proximity operations. Complete TLI burn with Orion. Oh, wow. That's even crazier, dude. Wow. That's nuts. That's nuts, dude. Yeah. That's gonna be a really, really awesome mission. They're gonna do partial insertion with. Nah, Thomas, dude. I don't think Orion has enough. Holy crap, dude! That mission is ballsier than Apollo 8. I'll just say that right now. Artemis 2 is gonna be even ballsier. That's a hard mission. That's a tough one. Element 3 things that make EJ mad. Rusty broken down. Ford's cancellation of the shuttle programs and the Minnesota Vikings. Oh, Element, I can't. Wait, what was that last part? The Minnesota. Oh, I can't hear you. You're going into a tunnel. Oh, your message. Sorry, your message got garbled. Parcel insertion. What type of eccentric orbit are we talking about here? That's awesome. Actually, I decided, Element, I'm really not mad at the Vikings. I mean, you guys probably will lose in the playoffs. It's fine. I'm really more pissed off at the NFL. It just made me not want to watch football anymore. Yeah, that game was abysmal. Yeah, I got better things to do on my Sunday. I mean, I'm probably still going to end up watching a little bit this week or on Thursday, but just stuff like that just makes it not fun. I didn't enjoy that. That was not a fun time. It was not a good game. It was a very poorly officiated game, but I don't really want to talk about football, dude. I'm just cleaning up the tabs over there. I mean, we got the Celtics and the Bruins to root for. Yeah. Mm-hmm. So he said that they dip into the atmosphere and skip. How long is that skip from the start to the dip to peak? Look up Apollo's return trajectory, Scully. It's pretty much that. They bounce off the atmosphere to mitigate cooling on the heat shield, so the heat shield doesn't overheat. Yeah, I just had to rub salt in the wound. It's okay. When your secondary gets railed when your defensive secondary gets railed in the playoffs, I'm gonna give you crap because you will. It's okay. It's all right. It's fine. What do I know? I just watch football every Sunday and have been for like 20 years. See last for an Apollo 13 related question. Okie dokie. What is about Artemis 2 being an insane mission? They're going to do RPOD and partial TLI insertion, which is just crazy to me. Were all the landing Apollo missions free return just in case? Yeah, They all started in free return just in case, and then when they would get to the moon, when they would get to periselene, they'd just burn the service module and then circularize in low lunar orbit. Yep. Love you, dude. Yeah. What's partial TLI? Partial translunar insertion. Can you explain free return? Yes. Yeah, give me one moment. So, Artemis 2 is what's called it's going to be a free return orbit. I'm just going to bring up the graphic here and I'll show you guys that. Here, take a look. So, the part that I think is nuts is part 6, 7, and 8. So, you know, it's going to launch. Everything's going to work fine. It's going to basically do exactly what...
Listen, Tranquility Base here. The Eagle has landed.
What the frick is this? What is this? What? Miscellaneous, very much overdue. Thank you? Thanks. I appreciate that. Thank you very much. So this is the part, Zay, that I think is really cool. See? ProxOps demonstration. So this thing will... The ICPS is going to put them into a highly eccentric orbit. So you see step 8 right here? Jeez. Thank you. I don't deserve that. Why do that instead of going straight to the moon? Because of this proximity operations demo, which is actually pretty crazy. That and I'm not sure. They're trying to do this free return here, so the delta V requirements are slightly different. But so this is the part that's nuts to me. 6, 7, and 8. So they're basically going to separate from the upper stage, and then Orion's going to turn around and not dock to it, but it's going to station keep with it. And those views are going to be really, really good. And then she's going to come back around, and then Orion's going to use the O-berth effect at step 9 here for TLI insertion. Translunar injection. They're going to do half of the burn with the stage and then half of the burn with the capsule. And my guess is that the reason why they want to do that is the ProxOps demonstration. And, well, not guess, they actually said it. Howard said it. Howard Hugh. He said it. They're just going to, actually it was Mike Seraphin. They're going to shake down all the life support systems and make sure the life support systems are working before they send it on a trajectory that's going to take days for it to come back. So they're just going to this is basically to make sure that the human rated element of Orion is working correctly. And then they're going to go do the mission out by the moon.
Listen, Tranquility Base here. The Eagle has landed.
Tannerin, that wasn't hokey. This one is, however. Did I miss something? Did I miss something? What did I do? Thank you? Oh. Why separate the ICPS if it hasn't used all of its fuel yet? Well, Cody, that's what I'm saying here. This graphic can't be right. This graphic is not right. This graphic is not even close to being right, like in terms of scale. The ICPS, the Orion service module does not have, dude, maybe 2,000 meters a second delta V. Maybe. There's no way it has more than that. There's not a chance. And in fact, I'm guessing it has way less than that. So if they're going to rely on the SPS, the Service Propulsion System, to finish up their translunar injection burn, what the frick? What's the semi-major accidents of step 8 here? What is that? That is an extremely high orbit. Yeah, Thomas, exactly like that. What type of orbit are we talking about here? Is free return more expensive than rectilinear halo orbit? No. No, Aquilux, you with free return, and so like I'm trying to get back to what I was explaining. Somebody asked me what free return is. Could you do the Artemis 1 and Artemis 2 mission in KSP? I think people would understand a little bit better if they saw it, including map. I'm trying to, Coley. I'm trying to get to that point, but we'll do that with a shuttle or something.
Listen, Tranquility Base here.
Who are you? Why are you doing this? I'm trying. What is happening right now? I don't understand. What did I do? Who are you? Wait a minute. Who are you? Jeez, thank you very much. Is it break day or something? I don't know what's happening, Nick. I'm Batman. So, would it make more sense for the orbit line to go from 12 to 8 than 7 to 13? No. Nah, or orbital mechanics doesn't really work like that, local. So, and sorry, man. Sorry, I got a little distracted there. It says 24-hour orbital period under 0.5. Now the real question is, Zeet, what orbits have high eccentricity? What orbits have high eccentricity with a 24-hour orbital period? Sun synchronous? Sun synchronous don't 24-hour, no. Sun synchronous orbits don't have a 24-hour orbital period, guys. They have a 90-minute orbital period. Molnia? It's a very high supersynchronous transfer. Yeah. Guys, that's past geo. That's past geostationary transfer. That's past supersynchronous, dudes. Think about it. Geostationary transfer takes 6 hours to get to apogee. It gets 6 hours. It takes 6 hours to get to 0.8. Dude, we're talking an apogee that is like 4 times as much. What in the frick is that orbit? That's insane. That's what I mean. That's absolutely nuts. That's way past geo. The apogee at parking orbit insertion is going to be insane. In KSP terms, it would almost touch the moon's SOI. Heck, in real life, that's what I mean. Jazos, the Orion Service Propulsion System does not have that much delta V to perform like a real low Earth orbit to low lunar orbit TLI burn. It doesn't even have enough to circularize in low lunar orbit. The apogee of the ICPS insertion is going to be about as close as you can get to a full TLI burn without actually doing it. Which is unfreaking real to me. That's insane. Correct me if I'm wrong, but that high parking orbit could be designed so it becomes lunar free return transfer for free after one orbit when the moon arrives, couldn't it? Just calculate TLI and launch one orbit early. Yeah, yeah, it could, except for step 9. Translunar injection by Orion's main engine. Lunar free return trajectory initiated with the service module. I mean, Adokin, to be honest with you, it basically is. I'm telling you that right now. It basically is. That's for the most part. If it went around again, it would probably get intercepted by the moon, but it wouldn't be on a free return trajectory. Think of step 9, if I'm looking at this right, as more of a course correction maneuver. And then once they do that, so what's a free return? Free return is a retrograde insertion around the moon. What is retrograde insertion? Basically, you're orbiting around the moon in the opposite direction that the moon goes around the Earth in. Now, the moon does spin. It does spin a little bit, sure, absolutely. The moon does, it spins around. The thing is, it doesn't spin around very much. It spins at 1 revolution per orbit, or basically tidally locked. It's basically one side is facing us at all times. So it is spinning, but it's just 1 revolution per orbit. It's always spinning in the same direction. Or it is spinning, but you get what I'm trying to say. If you don't, let me know. So, if you do a retrograde insertion around the moon, you can use the moon's gravity to pull you. You insert the opposite way that it's spinning. So you're actually going to slow down when you get near it because gravity does weird things like that. Fun fact, if you're spinning less, you can actually pull stuff in. The celestial bodies can pull stuff in. If you're spinning faster, you actually push stuff away with gravity. Yeah, weird, right? So I'll give you an example. The moon, right? The moon and Earth. Earth is spinning. Earth is spinning like crazy. That spinning force actually pushes the moon further away. Yeah, interesting, right? The moon's orbit increases a little bit every year. Yeah, funny how that works. But there's a planet like Mars. Mars has Phobos. Mars is not spinning very fast. And because Mars isn't spinning very fast, it's actually perturbing Phobos and pulling it in. Phobos will eventually crash into Mars. Not for a long time. But that's what it does. So the point is that you can use the moon basically spinning at 1 revolution per orbit, can basically pull a spacecraft in and shoot it out back towards Earth. That's what they're basically doing. They're trying to get to the moon. They're trying to put themselves into a lunar orbit that's basically going to shoot them on a free return back to Earth. And doing that goes basically you're inserting around the moon in the opposite direction that the moon is spinning in. And it uses gravity to actually just push you right back towards Earth. The Apollo program did that. Apollo 13 did that. Yeah, pretty much, Rarest. Yep. It's just a little bit of a safer mission than Apollo 8, huh? From the NSF article, following the ARB, Orion will separate from the ICPS into an orbit with an apogee of 59,000 miles. Perigee at 200, an orbit that will take 42 hours. 59,000. That's double geo. That's unbelievable. That's going to be a ridiculous orbit, Phil. How much delta V does it take to get in and out of low lunar orbit? Couple of kilometers a second.
Listen, Tranquility Base here. The Eagle has landed.
Who are you? Why do our orbits always look like an 8, like in this picture? If you go to land on the moon, why don't you go from 8 to 11 and then 10 to 7? These questions are getting hard to answer with Mr. Miscellaneous over there. You deserve this more than I. Jeez. Well, thank you. I do appreciate it. Is it Elon? I don't know. It's not me. I'm too busy with Elite. So, Jim, here, let me get you a trajectory view for Artemis 1, and maybe that'll help. The reason why it looks like figure eights is because this is showing lunar capture. So, technically this orbit, if the moon wasn't there, this TLI orbit, so 910, would look exactly the same. It would be eccentric. So, here. Long story short, how stuff moves around in gravity is freaking strange, dude. But if you kind of, these animations actually do make a lot of sense if you look at them. Check it out. So this is Artemis 1's trajectory. See what I mean? How much delta V did the Apollo CSM have? More than Orion does. The Super Heavy's done for the day. Does that make sense, dude? Look at that, Jim. That's what Orion is doing right now. Orion is right. So where it is right now is basically right here. It looks like a weird figure eight because when they launch it out there, the moon starts to pull it in. And I can give you another one. The other trajectory kind of shows this a little bit better. The reality is that it's in an elliptical orbit. And then when it gets to the highest point in its elliptical orbit, the moon pulls it and shoots it in a different direction because gravity. See? And then that's the distant retrograde orbit. The distant retrograde orbit looks really strange in this picture, but it's just an eccentric orbit around the moon. It's just another one of those. It looks like that, believe it or not, only a lot smaller. Whoop! See? And now she's orbiting around the moon, and it's gonna basically, and then it's gonna fly by the moon again, and then zip it right back down to Earth. Crazy, right? They're going to use the moon's gravity to slingshot them back towards Earth. All you need to do is just do some slight burns with the engines to put yourself on the right trajectory. This stuff is all on the Artemis 1 wiki page, believe it or not. Here, I'll show you. There's a lot of good stuff in there. Yeah, how stuff moves around in space is really, really weird. It's called orbital mechanics. Orbital mechanics are cool, man. You can do a lot of weird stuff with them. Now, Cody, I know this is going to be your next question. You know, you asked about Orion service module, then you asked about the Apollo service module. The Apollo service module has more delta V because Apollo is brute forcing it. Orion is much more kind of optimized with its service propulsion system to work with the Earth and the moon's gravity to get where it needs to go. That, and it doesn't need to go down to low lunar orbit. It has less delta V than the Orion CSM. Because it's just designed to go to Gateway. It doesn't need to go any further. And by further, I mean closer to the moon. Did it land, or is it going to land on the moon, or is it just a flyby? Stream chat, Artemis 2 is a crew flyby mission. Artemis 1, the trajectory that I just showed you, is happening right now, and it is uncrewed. Basically a bench test for the Orion capsule. I don't know who Miscellaneous is. But, yeah. What is Gateway? Gateway is a space station that NASA's going to put in a you want to talk about weird orbits, Merker. They're going to put it in a very strange orbit around the moon. Basically a lunar space station. But calling it that is a misnomer. It's not. That's the best way to describe it. But calling it that is not really the right thing to say. But, yeah, I'll say a smaller space station around the moon. Orion is supposed to basically get to this space station, and then another rocket will deliver a lander, or SLS will deliver a lander. They'll dock the lander to the space station, and then Orion will show up, and they'll get out of the capsule at the space station, and then they'll get in the lander and go down to the surface. But, dudes, the type of orbit that thing is in... It's called a near rectilinear halo orbit. Now, if you were having trouble understanding that free return, this one is going to screw with you. this one is going to screw with you a little bit. So, a rectilinear halo orbit, by definition, if we're just going to kind of describe what it looks like, It's a very elliptical orbit, so a very eccentric orbit. So one end of the orbit is really, really high, and the other one is really, really low. A distant retrograde orbit is kind of like that, but this is polar oriented. So at the lowest point of this NRHO orbit that I'm talking about, it goes over the north pole of the moon, and then at the highest point, it goes over the south pole. So we're talking about a big eccentric polar orbit around the moon. Hey, Port King's back, 31-month resub. See this and last one. Nope. In the middle of a Nope. In the middle of explaining it, Aqualux, and it's funny because I already have that video teed up. How far along is Gateway? Components of it are being made right now. Have you tried KSP with Principia? No, I haven't. And Reese, thank you for the sub. I try to shut up during the press conferences so you guys can hear NASA talk because I like listening to them. That's how I learn. So thank you. I do appreciate it. I know of Principia, though. But, okay, so here. This video kind of shows what I'm talking about. If we're just going to describe it, it's basically an eccentric polar orbit. But here's what it looks like going around the moon. Here we go. So, watch this one. This is the key for this rectilinear halo orbit. Long story short, orbits can stay on schedule, but everything in space is susceptible to gravitational perturbations from everything else. What does that mean? Everything affects everything. So Earth affects the moon affects Earth, right? Even stuff that's orbiting around the moon. The moon is not a perfect sphere. And even if it was, the center of mass of the moon is not directly in the center of the moon. The moon is kind of like a wobbly cluster of rocks. So is Earth. Earth is a wobbly cluster of rocks that's on fire. In the center. Yeah. So we have those plate tectonic things that are kind of going on. Yeah, it's just a big cluster of rocks with lava. It's like a lava jello mold. Kind of crazy, right? So,
Listen, Tranquility Base here. The Eagle has landed.
Your mom will affect the moon. Got him. Miscellaneous, do I know you? Like, this is long overdue. Do I even know who you are, or is it just miscellaneous? Like, do I... Like, thank you? Like, do I know you? This makes Earth sound super metal. Jonathan, part of the reason why I like space so much is because our solar system, the universe, the galaxy, it is the most metal stuff you've ever heard. The sun, for instance, the sun's gravitational pull is so ridiculously high. It's such a ridiculously big object, and it's so ridiculously dense that it literally takes hydrogen atoms and pushes them together and fuses them. It welds hydrogen together. That's why it's on fire. It's a fun fact. It's not fire. It's plasma. Yeah, it's like, that's what a star does. It is so, the gravitational pull is so ridiculously high. At an atomic level, atoms are squished together and fused, and that's why it releases so much energy. The universe is the most metal freaking place around, dude. It's like Viking metal going on up there. Everything's freaking on fire. And the stuff that's not on fire, there's usually just nothing there. Yeah.
Listen, Tranquility Base here. The Eagle has landed.
Yeah, Bluelin, I wouldn't be surprised at this point. So, everything affects everything. The Earth also, because it's a giant molten lava jello mold, has a non-uniform gravitational pull. And guys, this isn't some like, well, that's just your theory. No. Seriously, the gravitational acceleration on certain parts of the planet are actually lower. It's 9.80 or 9.811, you know, now 9.8 meters. Don't get me wrong. It's not that much of a difference, but it is enough to perturb a spacecraft that's orbiting around it. All right. The resulting forces from like a wobbly jello mold of a planet with a spacecraft orbiting around it is called precession. All right, so you can have orbits that precess around the Earth and orbits that precess around the moon. And basically, it'll change the orbit of the spacecraft because on one side of the planet, there's more gravity than the other side. Slightly more. It's not enough to really make that big of a difference. It's not enough certainly not enough for us to notice, right? So, the moon has the same thing. The moon, believe it or not, on the moon, there is orbits that can decay. You can have a low lunar orbit, space station in low lunar orbit, and believe it or not, it will eventually decay and crash. Yeah, the moon will pull it in slowly because of lunar precession. Now, let's get into something a little bit different with orbital mechanics, okay? So, with this precession, you can use it to your advantage if you know what you're doing. You guys ever see a thriller movie, a spy movie, and they're like, enhance, zoom in, enhance. The spy satellite zooms in and it kind of sees a guy like Enemy of the State where Will Smith's running around and stuff. You know, spy satellite, enhance, engage, enhance. Those types of satellites. Those satellites are in a style of orbit that uses Earth's precession to image the same spot every day. That is called a sun-synchronous orbit. Basically, when the satellite moves around, Earth's non-uniform gravity actually shifts its orbit a little bit, so at the same time, every day, it takes a picture over the same spot. I don't think I need to say why you would want to do something like that. You know, for instance, if you have, you're checking out the other guy's space launch complex, for instance. So sun-synchronous orbits use Earth's precession to actually stay over the same spot, and every time it goes by, at 8 a.m. local time, every day that satellite flies overhead. That's where all those spy satellites are. They're in sun-synchronous orbits. They use the Earth's precession to actually stay over the same spot almost every day. Now, when I say stay over the same spot, I mean it goes by at the same time every day. It doesn't sit there. That's a geostationary satellite. But the geostationary satellites are 23,000 miles that way, or 38,000 kilometers that way. You don't need a spy satellite that far away. That doesn't work very well. It's kind of easier to be a little bit closer, right? So those satellites up there, those aren't the spy satellites. Those are the antenna satellites up at Geo, but that's another story. And this is not just us. This is not just the U.S. Everyone does this. So it's not like exactly rocket science or some classified thing. Anyway, it kind of is, but it doesn't matter. So the moon has precession like that. The gateway. So if we put the gateway in low lunar orbit, it'll eventually fall back down unless we have put a thruster on it to keep it there. Just like the ISS in low Earth orbit needs a thruster, or the perturbing forces from the atmosphere and from precession will pull it right back in. If we ceased all operation on the ISS right now, it would come back down in a couple of months. It is a perpetually sinking ship, so to speak. And now, if we put a space station in low lunar orbit, same exact thing would happen. The moon would pull it in. But, just like there are sun-synchronous orbits for spy satellites around Earth, there are resonant stable orbits around the moon as well. The Lunar Reconnaissance Orbiter has been up there for 13 years now, and it uses the moon's precession, the non-uniform gravitational pull of the moon, to actually stay in the same orbit. It actually uses the lunar gravitational perturbations to stay in the same spot, or stay in the same orbit, not the same spot. It's a misnomer. So, what is one of Artemis's mission goals? Now, the Lunar Reconnaissance Orbiter is in a relatively equatorial orbit, more or less. Part of the Artemis mission's goals are to go to the north and south pole of the moon because there's water ice there. The Lunar Reconnaissance Orbiter actually figured that one out. Actually, I'm not sure where the Lunar Reconnaissance Orbiter, I'm not sure what that orbit is. But the LRO figured out that there's water ice on the moon, and you can use that to, make water, because you just melt it, you drink water. Also, water has hydrogen and oxygen. You can make rocket fuel with that. So a refueling place, long-term sustainable life support systems, etc., etc. So NASA needed a space station. I think, the LRO must be the Lunar Reconnaissance Orbiter must be highly inclined, but it's okay. So NASA is like, we want a nice resonant, a stable orbit to put a space station in, to basically make it as an outpost so we can get down to the surface. Now, in order, you need to be able to land at the poles, so it has to be a polar orbit to get near the poles, right? Now, the Lunar Reconnaissance Orbiter doesn't have to be in a polar orbit either, and it is stable, but it would be better to have something in a polar orbit so you could explore everywhere. Basically, anywhere that the Lunar Reconnaissance Orbiter was going, right? Now, don't get me wrong. We could just put a space station where the Lunar Reconnaissance Orbiter is. But to get down to low lunar orbit is an extra, probably, 2,000-3,000 meters a second delta V to get down there. If you stay in high lunar orbit and just deliver a bigger lander, right, you can make a spacecraft that doesn't necessarily have to get all the way down to the moon. That's where Orion comes in. So, we know that we need a space station that's in a polar orbit. We need a space station that uses lunar precession to stay stable, and something that has to be in a relatively high orbit. So here is what I'm talking about here. Watch this. This is the rectilinear halo orbit. This is where Gateway is going to end up. It is a highly eccentric polar orbit. Now, it is stable. But there's something that they figured out. There's something that NASA figured out with this type of orbit. Can you see what it is? Don't get me wrong. I've explained it before. Can you see something here that is interesting about the Gateway? Let's try to alleviate. No, nothing on Capstone yet. The rectilinear halo orbit is stable around the moon. You don't need to do much to change it to keep it there. But there's another thing. They figured out that using that same lunar precession, you can put a space station in an orbit around the moon that is always in constant line of sight with Earth. The space station always has line of sight on Earth at all times, because the moon is shifting its orbit slightly as it goes around. As the moon orbits around the Earth, the orbit always stays. Basically, see where these red lines are? They always cross the moon's white lines. So the orbit is always going to stay relative to the Earth and the moon. It's always going to stay perpendicular to that an imaginary line drawn between the Earth and the moon. Gateway is going there. The reason why it's going there is because if you put your space station in an orbit like this, you're killing two birds with one stone. Gateway is your relay. Gateway is the way to be able to get anywhere on the moon and have communications anywhere on the moon. No need for a relay system. Gateway is your relay system. Does that make sense? Because Gateway is always in constant line of sight, you don't need to worry about losing connection on the far side of the moon. Gateway will always have line of sight. Smart, huh? They paid some people a lot of money to think about this stuff. It's really, really smart. Like, really smart. And because because it's resonant, it uses the moon to stay in a nice stable orbit, and also uses that same lunar precession to stay in constant line of sight of Earth. It's a no-brainer. This is the reason why this is the reason why Orion doesn't have the delta V to get down to low lunar orbit, because it doesn't have to. It does not have to get down there. It just needs to get to Gateway. And then we can send up a lander, and the lander can finish off the rest of the delta V. And if you make the lander run off liquid hydrogen and liquid oxygen, you could just refuel the lander every time you land on the moon. Heck, something like Starship. Something like Starship is using methane. Okay, so ice is H2O. You can take that with a Sabatier reaction and take the H2 and separate it from the O. Now you have hydrogen and oxygen. If you bring a little bit of carbon up with you, guess what? You take the hydrogen and you combine the carbon to it and you make CH4, methane. You can refuel rockets with different fuels just by mining water. Pretty cool, huh? So you can have an orbiter that runs off methane, no problem. You can refuel it right on the moon. You just got to bring the carbon with you. Not too incredibly hard. Carbon is a little bit heavy though, but weight has nothing to do with it. Or you could find a way to extract carbon out of waste products. That might work. There's plenty of ways to do it. Moon water plus poop. There's no carbon on the moon itself? Nah, not really. But we do breathe out. We do breathe out carbon. Interesting. Cool, huh? NASA has, dude, they put in a lot of time thinking about this, guys. They have it figured out pretty well. But if you land on the North Pole, then when Gateway is going to the South Pole, is there not line of sight, no connection? Yeah, Violent, you figured out that there's not going to be a lot of connection there. But, so you got to think about how orbital periods work per eccentricity, okay? Now, so, if you have an orbit that has 0 eccentricity, dude, because that's actually a super freaking good question, okay? If you have an orbit that has 0 eccentricity, so a perfect circle, and you divided that orbit into thirds, let's say, right? You divide it into 3 parts, okay? The amount of time it gets from 0 to 1/3 to 2/3 to 0 again is going to be the same amount of time, right? Obviously. Perfectly circular orbit. And just pretend there's no perturbing forces at all, okay? It's going to take the same amount of time. Now, what happens if you're eccentric? The first third is going to take the least amount of time, but the second third and the third third are going to take the most amount of time. Second third and third third are going to be the same amount of time. They thought of this basically. They thought of this basically by basically coming up with this orbit here where you're out of line of sight for maybe 5 minutes. Remember how fast you're going to be going right here at periselene around the moon over the North Pole. You're going to be going extremely freaking fast. The Gateway will be. So it'll only be out of line of sight for 5 minutes.
Go at throttle up.
Because that's where it goes the fastest. 90% of its orbit will be over the South Pole in terms of orbital period. But yeah, there's a slight blackout for like a second, but that is nowhere near what you'd get if the station was in like low lunar orbit, or if you tried to make like some kind of communication system or some type of relay system around the moon. That's way more complicated because the moon will pull those damn satellites in. Remember, you can't really go that far out in lunar orbit before Earth will just pull a satellite back. So the area where you'd want a relay satellite isn't very stable. There's a lot of perturbing forces out there, mainly Earth, that will pull those satellites away. It's really hard to keep a satellite relay network going correctly around the moon. Gateway solves pretty much every single problem for maybe a 5-minute communications blackout per orbit. Gateway's orbit is going to take 2 to 3 weeks. Think about it. It's kind of similar to that retrograde orbit, that DRO orbit that NASA's Orion is in right now on Artemis 1. Look at how long it takes just to do one orbit. It takes a week. So for 5 minutes out of an orbit that takes a week, that's like minimal communication blackout. That's a good question, dude. Trying to manage a satellite network around the moon, dude, NASA looked at that and said, we're not doing that. That's dumb. A single relay satellite would solve that, like Gateway. Yeah, you could just have a relay satellite, right? You could just have 2 other satellites in the same orbit as Gateway, do the same thing. That's how the Russians maintain constant communications. Their communication satellites aren't in geostationary. They're in Molina orbits or lightning orbits. Yeah, like you could drop that. Yeah. I mean, composition of lunar soil. Ooh, very nice. There's aluminum up there. You could make aluminum tubes. Hey 2020, what's going on? Oops. Vehicle drove into a fireworks store. Nice. New theory. Gravity is just invisible rubber bands. You'd be able to hear them break when a probe gets to escape velocity if there was air in space. What about Lagrangian point relay? Not stable. Not stable, Hellfish. Really not stable. Yeah. They're not stable because of precession, dude. Precession will pull something out of those orbits really, really fast. That's why James Webb, for instance, orbits around the Lagrangian point. But it's using Earth-Sun L2, so the sun has more perturbing forces than Earth or anything else in the solar system. So it's kind of easier to orbit around that type of Lagrangian point. Between the Earth and the moon, no way, dude. No, it's not. It's not as stable as you might think. Everything is pulling on everything. It's like, it would be like trying to keep a buoy that's floating in the center of the ocean, in the deepest part of the ocean, trying to keep it in the same spot. That's really difficult. Could SLS ever bring a lander to Gateway to land with, or will they always need Starship to land? SLS in the Block 1B and the Block 2 variant could do an Apollo-style mission, Cody, if that's what you're asking. Once you have good infrastructure on the surface, it would make more sense just to make a communication tower instead of satellites. Sure. Yeah, of course. Would it be possible to place a satellite in orbit around the moon plus Earth? Berry Center, far enough out, maybe? Berry Center. Quills, refresh my memory. What does that mean? And on the long term, an Earth-Moon shuttle could use a high-efficiency engine. I haven't... Yeah, Caveman, I think I saw it briefly. I haven't... I saw it, but I haven't looked at it. You know what I mean? So they could just drive a ground communication relay on the lunar surface that faces Earth and run wires to the base. You're talking about building a radio antenna on another celestial body, TJ. Yes, they could do that. That's not exactly an easy thing to do. What materials are you going to use? How are you going to get them there? How's that going to work? You're going to refine metals off the surface? Okay, now you need a refinery. How are you going to bring that there? Point is, guys, is that down the road, yeah, you would build some infrastructure on the moon where you wouldn't necessarily need Gateway to do what you need to do, right? To communicate with Earth, not do what you need to do. But today, Junior. Berry Center is the center of mass between the two bodies. Think binary stars. Oh, yeah, that's right. Yes, Goalie, they will. I mean, you might be able to do that, dude. You might. You know what? Quills, I'm going to go ahead and say that I don't think that's stable enough, dude. That's just based off of kind of me picturing it in my head. It probably isn't stable enough. It's really hard to keep things in stable orbits. That's the reason why satellites only have a useful lifespan, like even out at geosynchronous and geostationary. I was about to say geosynchronous. Nice. Even out there, satellites have like 10, 15 year lifespan. And the reason isn't because the equipment doesn't work anymore. The electronics, the reason isn't because of that. It's because they run out of fuel. Straight up. They run out of fuel and you just fall out of orbit. The Berry Center is inside Earth. Yeah, I thought so. And if I had to guess just by knowing what I know about lunar gravitational pull and Earth's gravitational pull and Earth and lunar composition, I'm going to go ahead and guess that the Berry Center is somewhere in the mantle. Probably, I would guess like halfway through the mantle on Earth if I had to put my hat into the ring. So if Artemis 3 will be boots on the moon, what's the name of the mission that will do the uncrewed landing test of HLS? That's what I'm not getting. It'll be the super awesome SpaceX Artemis support HLS mission of awesome. It's not an Artemis mission. Call it Artemis 2.5. Den, I would like to add that Apollo missions weren't called Apollo missions until kind of like once they got around to like Apollo 8. That's when they started naming Apollo missions. Apollo 4 and Apollo 6 were retroactively named that. Yeah. In 1968, they were like, Even Apollo 1 was retroactively named Apollo 1. It was a plug-out test. It wasn't even a launch. But they called it Apollo 1. DM1 version 2, Block 3, FT, Disney Plus. Don't sue me. Max version missile. It's like World War I. World War I was not called World War I until World War II happened. It was called the Great War. It's still called the Great War. Founders Edition. Yeah. But microtransaction plus max version. Early missions were SA, later missions were AS. That's right. Yep. Yeah, Alex, I don't think it doesn't sound stable to me. Maybe they'll call it Artemis 2.5. Actually, I think it's called Lunar Landing Demonstration Mission 1. Lunar Landing Demonstration Mission 1. That's what it's called. If I remember, that's off the top of my head. I could be pulling that out of my tail. That sounds like SpaceX, and they do have a tentative name in like NASA PDFs and stuff. Yeah, or HLS Demo 1. It's something like that. I know it's demo. Did you figure out that issue with the craft file to make it work on TX's site? TX fixed it, Flykin. I know what I need to do to fix it. The video, top right picture. If you land on the South Pole, you will have longer connection than if you would land on the North Pole. Yes, and shorter connection when on the North Pole, like Russian satellites. Yeah, Violent. It's a Molina orbit for the moon. Yes. I answered you. Yeah. But the time the spacecraft spends over the North Pole is like maybe 5 to 10 minutes at best. So the orbit, a rectilinear halo orbit's orbital period is like a week. 5 to 10 minutes for basically being in line of sight for a week is pretty damn good. I'll take that. That's pretty good. Artemis Gaiden. Underrated reference, Rain. Earth Moon Berry Center is 2,900 miles from Earth's center. So, the mantle. All right. Naps, I was close. Nice. Artemis 2.69.420, version 1. Nice, Yuri. Revision A. Codename Dank. Demonstration flight named Demo must have been made by engineers. Engineers are not good at dealing with customers. They're not good at selling spaceflight, okay? They're not good at dealing with customers. So this is our Earth to Moon insertion burn. We're calling it translunar injection. What does it do? It moves something to the moon. This is our fing longer. What does it do? It makes your finger longer. Okay. Is this called the Artemis rocket then? No, Artemis is the name of the program, Stephen. Upgoer 5. Artemis is the name of the program. The entire concerted effort to get back to the moon. Like the Apollo program. So the Apollo program had the Saturn V rocket. Saturn V isn't called Apollo rocket, right? That's not right. That's not the right nomenclature. We have SLS, Space Launch System. Guess what that does? It launches things into space. I know. It's a great name. So it's not just a clever name. Who else? Crucial Taunt, they're just finishing a set. Here they can wail. You're right. Party on. Real name is Untitled Spacecraft. Yep. So they're just calling it SLS rocket. Yeah, Steven, it needs a name. Personally, I like Delta 5. Delta 5 is good because SLS is Delta 5. It is a Delta-derived launch vehicle, whether you like it or not. It's just kind of a joke that we have going around. It sure does suck. Well, as you can see, Dan, it sucks. And it cuts. You know they use suck cuts up on the International Space Station, dude? Have you watched Goodnight Oppie? Such a good documentary. No, Merc, I don't feel like crying over a robot that's like a couple 100 million miles away. It varies, okay? 2 different orbits. I'm down for Jupiter 4. No. Delta 5, okay? Delta 5 implies there were 4 deltas previously. There was 4 deltas previously, man. SLS sounds like a continuation of STS, though. It is. That's the quip on the name. Space Launch System is a shuttle-derived launch vehicle, so it uses a very similar naming convention. Because it's basically space transportation in an expendable capacity. Delta 3 didn't exist. Delta 3 existed! That does indeed look like a rocket. Delta 3 existed! Don't hate on Delta 8000. That's a good rocket. Well... See? SLS should be over here. Yeah, I agree. Delta 10,000. Yep. You have Delta 7,000, then Delta 8,000, then Delta 9,000. SLS is Delta 10,000, see? How? How is that true? Well, let's take a look here. Delta 3 had the Delta cryogenic second stage. It was basically a cut-down Delta 2 with more boosters and a Delta 4 cryogenic second stage. Delta 4 has a completely different first stage from Delta 3 and Delta 2, a Hydrolox space core with an RS-68. They completely changed the first stage, but they kept the second stage. Keeping the second stage in payload fairing from rocket to rocket per Delta nomenclature makes it so you can keep the name. Even though Delta 4 and Delta 3, the only thing really in common is the fairing in the upper stage, right? Still the same thing. Still the same Delta. Guess what, guys? Guess what upper stage SLS has? An interim cryogenic propulsion stage. It's a Delta 4 upper stage. Because you can take an upper stage off of one rocket and have a 3 nomenclature and put it on another rocket and has a 4 nomenclature, SLS is Delta 5. It is Delta 5 and you can't change my mind. See? See? Commonality. Boom. I don't know, Squishton. That's a good question. That's right, Naps. Mentioning Delta 3. Bold move, given its history. No, it's Ares 4. It's not Ares 4! No, Ares 4 was trash. That rocket sucked. Block 1B is 11,000 then. I see nothing wrong with this naming convention. I will call it Delta 5 from now on. How much Delta V will Delta 5 be capable of? I could tell you it in miles an hour. 25,000 miles an hour. Probably over, let's see, what would that be in metric? 11, 12,000 meters a second? Something like that? Depends on the payload. Poker, 24-month resub. So what's the name once it has the EUS? Delta 6! No, it doesn't matter. It'll still be Delta 5. It'll still be Delta 5 because Delta 4 had 2 different types of upper stages through the program and it kept the Delta 4 name. No, it's Delta 5. It's Delta 5 13,000 or 12,000. SLS is a Delta rocket. Yoki gifted a sub to Denjoga. Why not just call it the Saturn 6? Because screw Saturn. We got SLS. That's a nice rocket. I want Constellation. Oh, wait, something, $30 billion. You know what, 2020? I can turn the page. I can turn the page from Constellation, to be honest. You know why? You know, it still makes me kind of bitter, but you know why I can turn the page here? I'll show you with one picture. I'll show you with one picture. That's why. That's why. They're all Delta. Always has been. Hey, Jag. 1 year resub. Thank you very much. Omega 2. But Omega didn't fly, so it can't be that. Delta 3 did fly. It just flew badly. See this? See this? This is, I can get over the $30 billion thing because of this picture. Because of, got a weather minute. Because of this picture. See this? This is good. I like what's going on here. I like what's going on right in this area here. Not here or here so much, but right here. Yeah. Yeah, we can put that behind us. We can put that behind us. It will truly be put to rest when we put an EUS on top of this thing. Slap 2 more SRBs on it Kerbal style and call it Delta 5 Heavy, you know you want to. Well, technically, wouldn't an SLS rocket with 4 SRBs would not be Delta 4 heavy. It would be a Delta 5 4 medium. Delta 5 heavy would be 3 SLS cores. I saw it, Creeper, yeah. I don't think that it'd even get off the ground. Yeah, SLS is just Delta 5 medium. So it's Delta 5 42. Yeah, 42 would be the name. Delta 5 42. Oh, it would look amazing. Wouldn't it be cool? Shuttle Ares Delta derived vehicle. Sad. Pushes it.
Discovery, go at throttle up.
Yeah, I can kind of put the whole constellation thing to bed here. Almost.
Discovery,
Still say we need an Ares 1 style vehicle, but that's just me. Cyborg, 31 months, and Ein with a 27, and Kenwa with 100 bits. And thank you to whoever miscellaneous is. I still have no idea who you are. You are a gentleman or gentlewoman, lady, scholar, person. You're awesome. I love you. Thank you. Delta 5 medium implies the existence of Delta 4 heavy. Well, so they did change the upper stage. So technically SLS Block 1B, well no, that would be medium 5. Interesting. Miscellaneous is not hokey, that's for sure. Yeah. Not sure if anyone else has shared this project that a couple of friends of mine have been working on. Why would somebody share this project anyway? If you've heard about half-cat rocketry, they make pretty small liquid rocket engines and some liquid fuel rocket engines. Some of them are regen. Their next project is their full cat rocket, which is methanol and nitrous. Just like that engine that we were looking at a little bit earlier. Car engine. 650 pounds of thrust at 15 to 20 seconds. Sound on. Normally when people do the whole sound on thing, that means headphone users. So, headphone users, you have 5 seconds to comply. Didn't know 2020. Thank you for spoiling it for us. I appreciate it. Big shooter of engine. Today on How They Do It, Plumbuses. Oh, look at that side-by-side General Electric washer and dryer. Very nice. And that stainless water heater. That's... Oh, the rocket. Oh, yeah, that's good, too. Oh, yeah. The rocket's good. That's neat. I'm just kidding, man. That's cool. DJ is homeowner now. Dude, it's so bad that I noticed it. The really nice washing machine. What happened to me? I saw them up at the top right, Squish, yeah. No more claims you can't build liquid fuel rockets in your garage. Well, I'm gonna need a lathe. What tools do they have here? Very nice lathe. I have a drill press. Lathe again. Half cat. Lathe again. Drill press again. Now just use some kegs. Huh? Psst, your balls are showing. Bumblebee tuna. Project Keg Rocket. Word. Yeah, debatable. Home Depot bucket. Guys, you know what that means. You know what that means. Violent. I'll ask you. I'll check it in a second, dude. Let's jam for a moment. Anyway, so Violent, what was your question?
Discovery, go and throttle up.
Nick, thanks for the 46 months. I've seen this project on Reddit. I may have mentioned it to you at PAX one time. Really, 10. I know people that work on it. Apparently. Okay, Violent, what's your off-topic random question? I really don't know how to ask this, but can you explain how did we get here? I mean, if we have rockets, then we need steel. How do you make steel 200 years ago? A blacksmith. You need an oven that can smelt steel. Example, 300C. How do you make an oven 500 years ago that can handle 300C? That's a good question, man. A blast furnace will do it.
Go and throttle up.
A blast furnace, dude. Violent, this is one of the reasons why. You know how your boy's always over here just cramming down everybody's throats, you know, why we need to learn history and stuff. Dude, they could make steel 100 years ago. They could make steel 200 years ago. They could make steel 300 years ago. Of course. You could make steel. A blacksmith would need to do it. But you need a blast furnace. Actually, blast furnace didn't really come in. An induction furnace didn't come in until a little bit later. But long story short, you can make a kiln that will do this. You can make a kiln that will be able to melt steel, right? Basically what you got to do is you got to take iron ore, and then you got to take iron and you got to take a mixture of carbon and a couple of other things to make steel. You can do that with a ceramic oven. Rocks don't melt. They only melt when they get really, really freaking hot. But a blast furnace will do it. Blast furnaces have been used for a long time. Yeah, you can make steel a long time ago. There's a YouTube channel, actually, Violent, that I think you would really like. Anyone know what YouTube channel? You want to see how somebody would literally go from dirt to making metal? There's a YouTube channel for this. Tylen knows. So, Violent, you want to check out a channel called Primitive Technology. Primitive Technology is a channel where a guy literally does what you're talking about. You want to figure out how we got to where we are? Watch his channel. I'm serious. Aqualux, you already posted it? Yeah. Primitive Tech, actually, with his new series, he is showing how to get metal. How to get metal out of the ground when you have nothing but your hands in a forest. It's actually really cool. FPS Russia? No. I don't think he'll teach you how to do that. You'd learn a lot about metallurgy, lead metallurgy, on that channel. Fun fact, the first blast furnaces appeared in the 14th century and produced 1 ton per day. Oh yeah, long story short, we've been doing this for a long time. So, Violet, everybody likes to think that, the Industrial Revolution, the Renaissance happened, and then the Industrial Revolution happened after that, and that's when we learned how to do all this stuff. No. We knew how to do all this stuff. We learned how to industrialize it. We learned how to do it on scale. That's what the Industrial Revolution is. Taking the stuff that we already knew how to do and figuring out ways to do it faster and make more of it. That's all. Started with guns, and then a little bit later with cars, printing presses, Bigfoot. Yep. Yeah, glorious Nihon steel. Yep. We just figured out a way to do it a lot. That's all. And now again with rockets. Believe it or not, yeah, Dead Scum, that's a really good way to put that. Violent, we're figuring out, you're watching an industrial revolution with rocket science happen right now because people are figuring out literally how to make rockets in their garage. On the other end of that spectrum, people have been making rockets in their garages for a long time. Goddard did that, and he's the guy that invented the liquid fuel rocket engine. I digress. We're figuring out how to build large orbital class rockets and rocket engines in mass. Elon is doing that right now. If we don't get anything, if we end up not getting anything from like commercialization of space, that's something that we will get. That's one of the benefits that have already happened. Mass producing rocket engines, figuring out ways to make an assembly line for rocket engines where you can build them quick. That is one of the biggest gifts that SpaceX has kind of given because they figured out how to do it. We learned the importance of interchangeable parts. From firearms is the end of that sentence. But yes, interchangeable parts is a huge one. Yep. Steel has been around for a long time. Yeah, people have been making steel in different alloys for for really long periods of time. Yeah, Violent. How did we get here? A lot of fricking around and finding out over thousands of years, if you really want to know, just like anything else. And that's what's so dang cool to me, guys. Like, that's why, like, okay, a little bit of a weird note again. That's what's so freaking cool to me. Violent, I see something like a rocket. You know how many things we needed to figure out to build that? To build SLS? To build the space shuttle? You know how many things needed to go right? You know what I mean? Like, how many different pieces of technology and engineering does the space shuttle use, for instance? Or, I mean, you could even say SLS or even Falcon 9. We had to figure all that out. It didn't just manifest itself out of nowhere. Yeah, in real life tech tree. Yeah, war, don't get me wrong, guys. War drives a lot of that innovation. But, airplanes. Trains. Yeah, those two are really big ones, but that's another story. That is just my question. Dude, I see stuff like that, and I don't think people appreciate it enough. It's part of the reason why a Falcon 9, even though, like a Starlink launch, even though it's doing the same thing, I'll try to cover it as much as I can. I can't get enough of this stuff. It's ridiculous. Dude, even cars. Like, that's part of the reason why I like cars so much. Because look at this, the mechanized piece of equipment. I can just buy one. Are you kidding? Like, even a computer. I can just buy this? I can just go to the store and buy this? You gotta be kidding me. How many things, like, what the frick did it take to make that thing? To make my computers? To make the monitors? To make my car? Or an airplane? Or a skyscraper? How the frick do you even do that? Like, it's crazy, right? That's ridiculous. Aqualex, it is what it is. We ain't perfect, man. All right, mistakes were made. We like I said, we needed to do a lot of freaking around and finding out to get to this point in history, you know? Or the internet, yeah. Phones, like this freaking thing. Space program, you're welcome. Like, it's... We went from digging around in sticks in the dirt, right? 10,000 years ago to written languages, metallurgy, mechanical engineering, industrialization, and that led to computerization. Like, that, it's ridiculous to me. It is ridiculous. How do we do that? Like, it's unbelievable, isn't it? How do we do it? A lot of freaking around and a lot of finding out, man. Hamburgers? Yeah, medicine is even another one. And that's not even something that I even take for granted. Like, I even think about. Like, I mean, don't get me wrong. I do, but it's crazy, right? Mushrooms, yeah. Now, Violent, how did we get here? A lot of trial and error and a lot of death.
Discovery, go at throttle up.
Microprocessors are an embodiment of that Arthur C. Clarke quote. Yeah, dude. We live in such an insane time, dude. Think about what you're doing right now, watching me. I'm in a garage in the back of my property, just sitting here talking to a wall. But you can watch it from wherever you're from. No problem. Easy peasy. You can talk to me. That's absurd. That's ridiculous. Dude, I couldn't even imagine this job 20 years ago. When I was alive, let alone like can you like think about like our parents and stuff. This must be freaking like yeah, it is kind of like ridiculous future tech to them. Like they grew up with the Jetsons. We're pretty much there when it comes to stuff like this. How is this not a tricoder from Star Trek? It's the freaking same thing. So you're saying chat is a wall? Yes. EJ, tell me the truth. Are you on shrooms? No. It's just something that really, it's really overwhelming to me. Like think about how many things we needed to figure out to build like one of my crap box trucks. Like, think about like how many things needed to be figured out to make that. It's wild to me, dude. That's wild. What a freaking crazy world we live in. And we can see live pictures from a spacecraft orbiting around the moon. What the frick? How did we get here? That's awesome, dude. And that's why I like to learn history. That's why I like to know my history, to know how we got here. How did we get to this point? Look at that. Look at that. That's freaking nuts. It's ridiculous. Remember the sphere at Epcot? We're living in what the end ride looked like at the time. Yeah, I know, right? Unbelievable. My granddad grew up with a horse and buggy, flew planes in Korea, and then worked on computers later in life. Unbelievable, right? Yeah, I mean, Violent, I can't give you an exact thing, like exact dates as to when, like, certain stuff was made. Like, when did we figure out steel? When did we figure out iron? I mean, the iron was huge. Because if we don't figure out how to take the iron ore out of the ground and make it into a refined metal like that, the Industrial Revolution doesn't happen. But that wasn't a sequence of events. We knew how to make iron a long time ago. Way before the Industrial Revolution, That's crazy, Hokey. Repost, have you seen this? It even has mock diamonds. Most rocket engines do. If they're working correctly. Cool. Neat. How does Minecraft even exist? A simulation survival game. It's nuts, dude. They literally named ages off of metals that were available at the time. Yep. Iron Age, Bronze Age. Yep. Pretty cool, huh? Like, that's why I like learning history, because you learn all that stuff. It's really important to understand how we've gotten here. And, I do it to remind myself to not take this stuff for granted, because, I mean, it could be worse. It could be way worse, At school, I did not like history.
Go at throttle up.
I thought it's in the past. How is it going to help me today? But then I saw Kyle Hill saying a quote, "If we do not learn for history, it will repeat itself." it's a lesson. Violent history is a manual for what not to do. It's a manual for how not to do things. But also, for everything that we learn how not to do, we do learn good things. Right? There is good, and then there's a lot of bad. I think we focus more on the bad because those lessons are important to understand. But there's also a lot of good. I'll give you an example. And I got this from a Randall Munroe book. This example from it's another book called How To. Randall Munroe is the guy that does XKCD, right? He said it in How To. He basically said, does taking what was it? Hold on. Give me one moment. Does taking bacteria and putting it into a wound sound like a good idea? Does that sound like a good idea? Let me just take some bacteria and let me just smear it into this wound right here. Nothing bad will happen, right? Does that sound like a good idea? That sounds horrible, right? But that's how we figured out how penicillin works. That's how we figured out penicillin. Penicillin does that. It's not good. It is a bacteria. Fortunately, it's a good bacteria. You know what I mean? Right? Yeah, if it's bacteria eating bacteria, then yes, bingo. That sounds stupid. That sounds really dumb. And for the most part, it is. But, penicillin, though, floating, check this out, it's from 1946. Cool. No spot on Earth is more than 40 flying hours from your local airport. Spore me the details. Yeah. Even before that with pox during Civil War. Bingo. Crazy, right? If you ever get back into anime, check out Dr. Stone. It starts off with everyone getting turned into stone except the astronauts on the ISS. Then a civilization reset back to the Stone Age with some real science thrown in. That sounds like an anime, Electron. Thomas Wheel invented the wheel. I'll do you one better. The guy that invented the toilet's last name was Crapper. You think I'm kidding. Thomas Crapper. Go look it up. Thomas Crapper. Not kidding. That's cool, floating. We'll check it out. Booster return. What's that? Are you for real? No, I'm not kidding. The guy that invented the toilet's name was Thomas Crapper. This is a great shot, Thomas. Dude, look. You think I'm kidding? Do you think I could whip up this Wikipedia page in 2 seconds? No. No crap. No, there was. Dude, I'm not kidding. It's exactly where the phrase comes from. Exactly. Predominant, yeah. See, that's what's cool about history, you know, because we can just learn from other people freaking up. You ever hang around with a group of your buddies and some guy's like, I'm gonna go jump off the roof. And then he does it and the guy's like, ah, and then everyone's like, oh man, that looks painful. We probably shouldn't do that anymore. That's history in a nutshell. It's true. Don't jump off roofs. You learned that in the early 80s or watch it when I was in high school. There you go. So when can we say, I'm going to EJ this into orbit? Yeah. that's why I love learning history so much, dude. And that's why, like, the other thing, just it's predominant. You're right. You have to take good with bad. You have to understand that not everybody in history is an angel. That's such an important thing to learn. Not everybody's an angel, dude. There are some people that your role models did some really messed up stuff. I'll take one of mine, for example. There's a reason why I like Ford so much, is because I think the moving assembly line, the invention of the moving assembly line is one of the benefits to modern society that we benefit from. It's one of the single greatest industrial innovations ever. Henry Ford is the one that came up with it. Henry Ford was also a jerk. He was not a good person. But I can acknowledge that he was a dick, but he had good ideas. So what I'm going to do is I'm going to take all the stuff that made him a dick and just leave that over there and take the good stuff. That's learning from history. You have to do this. If we don't do this, how do we know what's good and what's bad? Yeah, Richard Gatling was a pacifist. That's right. The guy that invented the Gatling gun. His mind was in the right place, but didn't really work too much. It didn't work as intended. Because you should never underestimate our ability to blow each other up. The guy that invented the Gatling gun, he invented it. He was a pacifist. He invented it as a means of deterrence. No one's going to want to fight against this thing. If everyone has these, no one's going to fight against each other. Right idea. It took another couple hundred years, and the adaptation of being able to split molecules at the atomic level to get to that whole deterrence point. But it's on the right track. Not before millions of people died, a lot of them at the hands to a Gatling gun. But right idea. Yeah, Von Braun's another good example. Yeah. Yes, I talk about Von Braun and I talk about all his great ideas. And people are like, oh, he was an SS officer. Yeah, I know. That part is not good. The rocket part is good, though. We should just take that and the hell with the other part. We don't need that part. Screw that. Send that part back to the annals of history, please. I really like Vice Grip's Urbex from the Ford factory. I'd say he could make another channel out of that content if he wasn't so busy. It was really good, man. I was near Highland Park the other day. Browning, Stoner, Nobel. Yeah, the Nobel Peace Prize. You guys know what Alfred Nobel became famous for? Inventing dynamite. They named a Peace Prize after him. Yeah, TNT, technically. Trinitrotoluene. Yeah, TNT, not dynamite, but you get the idea. Crazy, right? It's important to learn that stuff, Violent, because then it just makes you appreciate stuff like this even more. Yeah, Squishton, that makes sense. That just makes me appreciate stuff like this. Stuff like this. Oh, it's so damn cool. Whenever you see me geek out about this stuff, when I'm like, oh man, that's awesome. That's the kind of stuff I'm thinking about. You know how much effort it took for somebody to figure something like this out? You know how, like, all the technologies that needed to have been there, the tech tree that needed to be there, to get to the point where we can do studies on different type of resonant, stable, constant line of sight orbits around the moon. Unfreaking believable. Crazy, isn't it? It's cool, man. Now, don't get me wrong, Violent and everybody else, you're sitting there going, oh, this is kind of overwhelming. Yeah, it is. It is. You're nuts, dude. Oh, there you go, Aqualex, yeah. Question, this kind of orbit was calculated recently or the Apollo era? No. Rectilinear halo orbits, they didn't really figure that stuff out until a little bit later. The Apollo program, like I said, alleviate. You know how you try to land something on the moon in KSP, where you circularize around the moon and then land. That's what the Apollo program did. They basically brute forced it to the lunar surface, and it worked. Now, don't get me wrong. It's not to undermine the effort of 400,000 people during the Apollo program. Brute forcing it to orbit takes an insane amount of expertise, and to be honest with you, it's probably harder than what we're doing right now. But I have a good one for you. The father of modern chemical warfare also created synthetic nitrate fertilizers. His weapons killed hundreds of thousands and fed billions. Yeah, somebody, Hellfish, was that you? Somebody said that a second ago. What is that red portion of the overlay? The orbit. That's the orbital track, Evil Race. I feel like a lot of people do not appreciate the modern time. Phone, cars, electricity. Well, Violent, part of the reason why I teach what I teach here is to make people understand that. There's a reason why I go work on the trucks, dude. I mean, that and because I like it. But the reason why I like it is because it's ridiculous that I have something that can just move me around at the turn of a freaking key. Guys, over on vacation, Brimo and I got into a car and drove 900 miles to Michigan. No problem. We didn't need to worry about food. We didn't need to worry about gas. It's everywhere. We didn't need to worry about any of that. It's fine. You could just drive to Michigan. All right. So that's 900 miles. That's 1,500 kilometers. Yeah, no problem. Whatever. Does that not like... That's why I love driving around. That's why I love doing Route 154. Does anybody else not just... I don't understand how someone can just look at that and be like, all right, you drove to Michigan. So what? Like, bro. You know how hard that would have been to do 100 years ago? Hello? You know how hard that would be to do in 1922? That would be nigh impossible. At the expense of our atmosphere, yeah, Iger, something, take the good with the bad. Violent, I drove my truck across a continent. A continent. I did it in a couple of days. Well, it took a week because the wheel fell off, but a week? A week. That's fascinating to me. It's fascinating. Dude, that's why. Maybe I'm just easily excited. I don't know. Probably. I mean, you yelled at a freaking rocket on the way up, like. Yeah, the wheel fell off. Impy, I drove the wheels off of that thing, okay? I got a huge surprise today. My dad's taking me to the Silverstone Grand Prix for your 30th birthday. Ooh. Ooh. You picked a fine time to leave me, loose wheel. Yeah. Jam dead. Nice. Now do it in a day. No. I'll take a wheel falling off instead of a leg falling off. Yeah, Panda Man. You watch 1883? Funny how that works. It took years the first time a white man did that trek, dude. Never mind freaking European settlers, Aqualex. If you wanted to move your tribe across this country, it was going to take a while. You don't want to be considered in the same breath as AJ Foyt, who ran the first cannonball? I don't think it's possible for me to do something like that. Well, I don't think it's possible for me to do something like that legally, and I wouldn't break the law, Hellfish, because breaking the law is wrong and reprehensible. If you want to drive a car fast, you drive it on the racetrack, because breaking traffic laws is bad and it's a felony, and you can go to jail for it. Yeah, only stars and lords for direction. Yep. I was marking that as a moment in time. Yeah, I got you, dude. It's not Judas Priest do it all the time. I don't know what you're talking about, guys. Breaking the law is bad, and I wouldn't condone doing it in a public forum like this. See last, I'm so confused by Ferrari. Latest out of Ferrari. Feast your eyes on the Ferrari Vision Gran Turismo, Maranello's first car designed specifically for the virtual motorsport world. You see this? Alleviate. This is why Ferrari loses. Okay? Okay. This is why, this right here, this is why Ferrari does not win Formula One races. Because this is clearly something that is important. But anyway, Violent, you should learn your history. Learn it. Learn your country's history. Learn other countries' history. That's what I do. There's a reason why I'm so good at geography, because I want to learn. I want to learn about every country and every country's history, because everything can bring something to the table. It's so important to understand that. You once said something about if you can point in a problem, you can fix it. What was that quote again? The quote is, it's easy to sit there and point out a problem. It takes skills to be able to fix it. Anyone can sit there and say that this is wrong, this is bad. What are you doing to fix it? Ferrari spent their time wind tunnel testing that instead of their F1 car. Yeah, I wouldn't be surprised, Cody. I thought that was because the team is overly nationalistic and won't hire based on talent. Stubborn Italians, selfish. Case in point, stubborn Italians, dude. For the Australians, you learn not to fight the emus. Yeah. Blinga, actually, something interesting I learned about Australia. You know, everybody knows, penal colony, right? But what they didn't tell people is that if you did go to Australia and you worked in a penal colony, you work off your sentence and then they give you land in Australia. They fail to mention that part most of the time. No, Swiston. As further punishment, they give you land in Australia. Granted, indigenous people's land. Yeah, the Aborigines didn't really like that. Yeah, Aborigines didn't really like that. But like I said, there's dark and then there's good. There's dark and then there's light. There's good and bad, and it's important to understand those things. Did they actually go through on their end? What do you mean, Hayes? Yeah, of course. It was just other people's land, but yeah. Yeah, Blinga, we all did. So did we in the States, man. Yeah, absolutely. But like I said, you gotta understand that. We can't just sit there and say that, oh, we took advantage of indigenous people. You could sit there and say that that's wrong. And like I said, you want to do something about it, do something about it. But you have to acknowledge good and bad. You can't change that. You can't change that history. You could try to rectify the situation if you want. But like I said, there are points in history where you say, yeah, that was probably a bad idea. We probably shouldn't do that anymore. But does that mean, oh, because we did that, our entire culture doesn't matter anymore? It's because it's predicated off of bad stuff that happened? No. That's how we learn. That's how we get better. Make sure to not do that again. Probably a good idea. Huh. I like that picture, Jazos. Here. Yeah. Yeah, that picture doesn't suck. Pretty good idea to do something to make up for it. Make up for the past? That doesn't sound right to me. Have you seen the moon tonight? I'm looking at it right there. Best thing about that picture is that it isn't 50 years old. Indeed, man. When we get the 4K footage, it's all recorded locally, Alleviate, but that picture is not too bad considering it was beamed 430,000, or no, what was it? Yeah, 430,000 kilometers. Yeah. This picture was taken about 430,000 kilometers away from Earth. So what is that, like 270,000 miles? That's pretty good. Was the worm Jim's idea? Quite possibly, Blinga, yeah. Bottom left RCS, yep. Pretty much off-the-shelf cameras. From what I understand, floating, they're GoPros. They're Hero 4s. See, flat earthers complaining about the moon looks bigger than Earth, not realizing Orion is closer to the moon. I don't let those people occupy my headspace, TJ, but I understand what you're saying. You seem convinced of that, Aqualux. Let's see. Looks like the moon needs a makeover. Sizz it up a bit. Add a little bit of bling. Yeah, I'm kind of with you on that one. We should go there. What's VSVN? I don't know what that means. Why are there no stars in the pic? Okay, Wollo. Okay, I will ask. Are you actually asking or are you trolling me? Because people troll me with this question all the time. And I don't mind a good trolling from time to time. If you can really piss me off, then good on you. That's how the internet works, all right? You're going to get the short end of a stick. But if you're actually asking, all right, so you ever spin in front of a car in the middle of the night? Honest question. Hopefully it wasn't moving. You ever been in front of a car in the middle of the night? Can you see the driver? Why not? Because there's two big bright lights in the way. The stars are there. But there's one star that's a lot closer than all the other stars, and it's a lot brighter because it's closer. Actually, it's not very bright compared to the other stars. There are stars that are brighter than ours. But that star is way freaking closer than all the other stars. So when you try to take a picture of it with a camera lens, unless you went for an extremely high exposure, like what Hubble would do, or James Webb, you're not going to see them. Because the light from one star is drowning out all the other ones. So why can you see stars on Earth then? When can you see stars on Earth? At night? When the Earth is blocking out sunlight. Makes sense, right? Now, don't get me wrong. You can see stars during the day. But most likely, the things that you're seeing up there during the day aren't stars, they're planets. In which case, you're seeing reflected sunlight off of said planet. Does that make sense, dude? And the other thing is that if you, with the right camera lens, you could see stars during the day. Sure, why not? These cameras aren't the best. There are better cameras. Yes and no. Where are you getting confused, dude? Someone in my geography class thought the sun and the moon were the same thing and just flipped it at night. I really hope that was like a middle school geography class, Alleviate. I really hope you were like 12 or something. Because if that 15... Also couldn't grasp why we didn't dig to Australia because it's quicker. How do you feel about flat earthers, Schnoid? If someone's going to come at me with a legitimate argument and be open and willing to have their mind changed, heck, if even someone's like, dude, the bar is so low with that kind of stuff that if somebody's just willing to not be a dick about it, I'll talk to them. But for the most part, I don't let those people occupy my headspace. Orange bottle, good. I don't let them bother me. I don't look at this picture and say, "Ha, take that, flat earthers." I don't look at this picture because frick them. I don't let those people. I don't worry about those people. It's like the not the Ron Swanson meme. It's the Mad Men meme. I don't think about you at all. I don't let you occupy my headspace. You do not live in here. Okay? No rent-free stuff going on here. I look at that and say, that's the frickin' Earth and the moon. That's cool. Your round headspace? Checkmate. Why would I let them bother me? That's like if someone comes up to you and says, "Hey, 2 + 2 = chair." Did you know that? I bet you didn't know that. 2 + 2 = chair. Yeah. They have you thinking it's 4. It's not. It's chair. What would you do to that person? What would you say to this person if they stopped you on the street and said that? I'd be like, all right, man. Yeah, chair. Excellent. I love chairs. I sit in one all day. All right, see you later. I'm going to leave now. No, 2 + 2 = fish. All right, chat. Yeah, that's great. I'm going to leave now. All right, man. Yeah, no. Sure. I've seen the pictures. Mars is flat, too. All right, man. Enjoy your week. TJ, whatever, dude. So here's the thing. This is another lesson that history teaches, TJ. Say every person out there that thought that the Earth was flat, every single person, say we were able to convince them. We were able to convince every single person, and the flat Earth problem didn't exist anymore. Guess what? A different group of people would just find another freaking thing with spaceflight to freaking be like, nope, that didn't happen. Because guess what? Flat earthers and moon landing deniers are not the same people. You'd still have the moon landing deniers. Even if you took every moon landing denier person and somehow was able to convince all their minds, there'd still be flat earthers. And if we convince them too, then there's going to be pancake moon conspiracy theorists. The moon is a pancake. The moon's made out of cheese. No, it's a pancake. And people would find a way to fight over that. Okay? It's not really, this is why I don't let it occupy my headspace. It's not really about the Earth being flat or it being an oblate spheroid with perturbing gravitational effects, okay? It's not about one or the other. People like arguing. Look at the internet. People love arguing. People like arguing. SLS versus Starship. Ford versus Chevy. Patriots versus Vikings, even though the Vikings suck and I hate them and everything from Minnesota is terrible. People like arguing about everything. That's how it is. That's why I don't let it bother me. Who cares? Who cares? It's irrelevant. It doesn't matter. Those people hollering and hooting about all this random stuff. The Earth's a disc and we're flying on a turtle. Guess what? That doesn't change the fact that this picture exists, boy. That doesn't change the fact that this picture is real. That must suck. That must suck to have proof right in your face and just not be like, no, that's not a thing. All right. 2 + 2 = chair. See what I mean? No, people don't like the fact. No. Prince is overrated, Badger. I hate that guy. We're not partying like it's 1999. Yeah, spoiler alert, Prince. That song got old in the year 2000. What's wrong with you? Let's go, Blues. Don't you dare. Don't you dare do that to me. You know, a 4 does kind of look like a chair depending on how you write it. Oh no! Oh no! Oh no! Damn it, Cheddar! Okay, maybe 2 plus 2 does equal fish. Okay. Leglander, thanks for the raid. They were right all along! Oh, I wrote that guy off. Oh, I'm such a jerk. That's awesome. 2 plus 2 does equal chair. Oh my goodness. Oh, that's a cool thread, Elfish. Congratulations. You just played yourself. So that's why, basically, fellas, my rule with people that disagree with me about like space and stuff, dude. As long as you're not a dick, I don't really care. I'll talk with you. All right, whatever. Let's chill. Check the raid. The Laglander raid. Shut it down! Shut it down now! And Vegas Air had a 20-month resub in there. Shotzi, how are you? And then we get rated with a 4 to... I'm leaving. I'm leaving. I'm leaving. I'm out. No. Did you just take a piss outside? No. Yeah. Yeah. Hey, it was a good segue. It was a good segue. Don't say that it wasn't. I didn't want to start a chair like Lander. How could you? I made yellow snow. There's no snow outside. There's marking territory. There you go. I'm curious, kind of curious with navigation in deep space instead of star trackers. What other software could you use? Inertial navigation, T-Man. Inertial navigation. Basically, take the spacecraft's last known point of origin and use that as a datum, and then use your acceleration and the direction relative to the last point that you were tracked with to basically figure out where you're going. That's what the missile knows where it is. That's what that saying, that meme is about. The missile knows where it is, so it knows where it isn't. That's about inertial navigation systems. Planes have inertial navigation. Spacecraft have inertial navigation. Heck, I'll bet you ships do too in some way, shape, or form, but ships are probably using GPS more than anything. Did you smoke and yell and finish? Yes. Oh, malauta. Bramny Vans, 60 G's. I'm old now. Only dogs and degens pee outside, shaking my head. I think you're just mad because you can't do that. Satana! Equation derivatives, yep. EJSA has 4 letters.
Discovery, go at throttle up.
Excuse me? Oh god. Oh god. Alright, now I'm really leaving. She's mad. Run. I just joined and this looks like an acid trip. Thank you. Space Shark, what do you think about this? Hiding behind the Ford. Hi, Figs. I'm happy that I'm alive and can see that. I'm right there with you. Yeah, I'm right there with you. It's pretty freaking cool, dude. Believe it or not, that's what spurred that whole conversation, but, you know. Thanks for the laugh, you needed. I'm good. I got you. All good. I said I'm good. Tori, that's good. Here, just... Alright, there we go. All good. No problem. What's VSVN mean? On the spacecraft, what are those little nozzle things on the body? Let me take a look. Talking about those things right there? Those thingamajiggers? Or are we talking about those thingamajiggers? Because those thingamajiggers are not the same things as those thingamajiggers right there. Impressive. Very nice. No. On the white part. Just up from the RCS. These guys? Solar panel holders. Most impressive. Okay, Figs, dumb question. How could it be called a human-rated vehicle if the current configuration can actually support humans, aka no life support? Human rating basically stems from design, dude, not performance. All this is doing is validating their analysis. That and life support systems are really easy to test down here. It's really easy to see if a life support system is or isn't going to work. So human rating is something that's incorporated into the design. Orion is human rated. It's not certified for human rating. Does that make sense?
Discovery, go at throttle up.
Just like Falcon 9. Falcon 9 was human rated from the start. But it wasn't certified for human rating until DM1 flew. Actually, they certified it a day before DM2 for human spaceflight, actually, if you really want to know. So, there's human rating a vehicle, and then there's human rating certification. Orion is a human-rated vehicle, but it's not rated for... It's not put... I wouldn't fly in it right now. There's no life support system. They have to get it ready to go.
Discovery,
now,
go at throttle up.
It has chairs? Yes, but the chairs don't have 4 legs. They're bolted to the ground. By ground, I mean the inside of spacecraft. Artemis, I like that. Sorry for the low quality. That's what the Artemis logo is, dude. That's pretty cool. It has 4 solar panels, though. Are they bolted down with 4 bolts? The solar panels? Correct. Yeah, when the solar panels are in that stowed configuration, yes. There's 2 right there and 2 right there. And then if we could see here, let me get a picture of Orion with the solars. So images.nasa.gov. We'll find a picture of it with the solar panels. It's in here somewhere. You can see that the solar panels have bolt holes in them. Oh, there we go. This one will work. Also a really nice picture. Yeah, see? 1, 2, 3, and 4. So the solar panels have a pin, and when they fold over, that pin skewers the solar panel like a shish kebab. And then when they wanted to deploy them, the pins pop out. They either pop out or they just retract or something. I'm not. Oh no, the pins are right there. Oh, they're right. Frick me, that's smart. Wait, how does that even work? Oh, there they are. Dude, that's got to be like a zip tie or something. Huh. Did you guys know that each one of Orion's solar panels can generate 13 kilowatts of power from one solar panel? 13 kilowatts of power. 13,000 watts. That's enough to power a house. One of those things. What? Crazy, right? Prior to deployment, the wing was held in a stowed position by 4 Kevlar straps. When an Airbus Netherlands test engineer issued a command for the wing to deploy, thermal knives cut the straps to release the wing array. This design included 2 thermal knives for each strap for redundancy. And Thomas, you know what? If we go back and look, there's your 2 thermal knives right there. 1, 2. Cool, man. Yeah, those are the solar panel mounts to make sure they don't weeble wobble around on liftoff. Alleviate, anything else? Anything else you wanted to ask about? Should have used plasma knives? Can that power a gaming PC? T-Man, 13,000 kilowatts can power your whole house, and probably your neighbors too. Yeah. It's kilowatt hours, Snatcher. That was my assumption, that it was kilowatt hours. Just enough for a 4090, indeed. Okay, on the Orion capsule, what were the nozzles you pointed out at the beginning? Well, those are RCS right there. That's RCS for roll control, right? Because they need to roll the capsule during re-entry to change the angle of attack on the heat shield, right? Anybody know what those are? Who knows? I'm curious. Holes? Damn. How'd you know? Is it RCS? Twinkie holders? I mean, you could use it as a Twinkie holder. It's probably not advised. Strobe lights for the party. Well, it has those, but those are inside. RCS. Why? So if those are RCS, why would that thruster exist right there? You said 13,000 kilowatts, 13,000 watts. Yeah. I know. I said that, Chief, but I figured you'd give me the benefit of the doubt that I might just be misspeaking, but apparently not. You don't re-enter with the trunk on. Well, why would you? So the other question here, Ray, is why would you have a translation thruster here? Reverse with RCS? That's what that thruster is for. You got to balance out the RCS? Maybe. So don't you think there would be some in other spots? I'm actually seeing it. I'm seeing it. What do you got? Let's think. This is how I think about things, guys. I'm actually seeing. Who knows? Who knows? Let's find another shot of Orion. Really nice pictures of the pad getting absolutely blown away right there. It's not translation, it's pitch before it hits the atmosphere. Pitch without the service module? How are you going to do that with a capsule? What I know about spacecrafts? That's what you're here for. Okay, that's fair. Was that an elevator door? Do they have the elevator door picture here? Oh. That was an elevator door. Could you show the holes again? Sure.
Delivery. Go at throttle up.
Is it RCS? Or is it a star tracker? You guys tell me. Expandable elevator door. Yep, expendable. Something tells me that reusable elevator doors would probably be cheaper. Yeah, triplicative. I got you. Sure. Back it up. So, is this what you want right here? You go for the star trackers? I think that's a star tracker. Maybe. How can you know? Door. Is there any conclusive way to know what that is? Where's Jimmy Neutron? Probably at his fat friend's house. I forget it. Carl's house. Yes. Yeah, no problem, Trip. 13,000 kilowatt panel would be nice. Yeah, I wish. That would power an entire city. Why are there two RCS pods in one section and then just one on the other? Guys, it's RCS. I'm pretty damn sure. That's RCS. The giveaway is this ring that's around it. That's not the star trackers. The star trackers are somewhere else. See that? Thermal. There's a thermal component around the thruster. There's thermal components there. Those are translational thrusters. They're translation thrusters. Or they could be reverse thrusters. I'd have to really see which way the nozzle is pointing. But it's definitely RCS. That could be for slowing down, but I doubt it. I think they go that way, not that way. Didn't you say that it wasn't? I must have misheard. I did, someone. I want to... Okay, I do that sometimes, dude. That wasn't a misspeak on my part. I do that from time to time to see if people actually are using their brains or they're just regurgitating what I'm saying. It's kind of a test with the loaded question in it. It's definitely RCS. But the whole point of the exercise was to prove that it's RCS.
Go at throttle up.
Well, a good way to prove that it's RCS is that it has the same thermal component as the RCS that's right there. And I know for a fact that that's RCS because it's pointed left-right. And that's very similar. So it's got to be RCS. It can't be star trackers. I wanted to... So yeah, that's kind of from time to time see if people are not just like regurgitating what I'm saying. Now there you go, goalie. There's your star trackers. Why are there two RCS on one and then just have one on the others? Because the capsule needs to maneuver at certain points in the mission, Cody, without the service module attached to it. You need RCS to steer going through reentry. You don't just do a ballistic reentry. That's how people die. Yeah, you don't want to do that. So after the service module separates, you're still going to need RCS on the capsule. Here, I'll give you a hint where they figured that idea out. See what I mean? But these thrusters here aren't necessarily... It's interesting because these thrusters, the thrusters on the capsule, those are for pitch, right? You can pitch the capsule, but pitching the capsule isn't going to work. The roll thrusters are the important ones. The roll thrusters on a capsule are important. Orion has them right there. But they also have translational thrusters. That translate thruster is probably there to counterbalance that, so Orion can do RPOD, rendezvous proximity operations and docking, if I had to guess. They probably balance these thrusters with that thruster there to get the capsule to translate and move around, right? But those thrusters are, so you guys want to get into a little bit of trigonometry here. Those thrusters are at 45 degrees. Those thrusters are pointed straight up, right? So if you have a thruster that's pointed at 45 degrees, two thrusters this way pointed at 45, right? And then you have two thrusters pointed straight up like this. Firing just two of these thrusters and these thrusters are not going to give you a balanced thrust. Why? Well, these are at 45 degrees. That's going to make you go that way. But if you have four thrusters, two of them and two of them like this at 45 degrees, and then you have two of them that are pointed straight up, those two thrusters, when they fire, will give the exact same amount of thrust as two thrusters pointed straight up. Pretty cool, huh? That's called cosine thrust loss. It's something that has to do with trig. Pretty interesting, huh? Also, door. I mean, didn't those guys pull upwards of 7 Gs on reentry on that Soyuz abort? And that was just suborbital. Think of reentering from the moon. Milkshake. Milkshake. Trig broke up with her back in high school. No, look at a picture of the whole service module. One section has 2 RCS pods and the others have just 1. I have no idea what you're talking about. Yep. I have no idea. Yeah, Cody, I have no idea. There's definitely 4 thrusters right there, and then there's 4 right there. Yeah, I don't know what you mean. I see 4 thrusters right there. And I'll bet you money that those thrusters work in conjunction with that thruster right there to get the thing to move this way. I think I've learned more random but awesome things watching you stream for a few days than I ever did in your college engineering classes. Nice. All right. Yeah. Birch. I read those papers all the time. Those papers are like, you know, you do college engineering, you do the math and stuff. That's all fine and dandy, dude. But at some point, you just got to explain what the damn thing does. You know, like cosine thrust, like 4 thrusters at 45 degrees are going to give you the exact same imparted force as 2 thrusters pointed straight up. Why? Because they're at 45 degrees. Like, that's not... It's not rocket science. Nikes. Yes, it is. But yeah, that's awesome, man. That's good to hear. I'm glad. Trying to visualize this stuff is the biggest problem that I encountered when I was like, oh, I got to learn all this. And then I went and read a technical paper. I'm like... I don't know what any of this means. All right, that's cool. I guess I'll just go not learn this then. Yeah, it was all math and more math with a little programming thrown in. Well, that's good too, I guess. Actually, it's trigonometry. Yeah, you're not wrong. All right, let's see. Let's see what we got. Yep, roll and yaw. There you go. Oh, that's freaking sick, dude. So, see this? Capsules are actually lopsided. Not a lot of people know this. And Aqualex, thank you for the PDF. Capsules are lopsided. The center of mass is actually towards one side. Think about it. You got the people sitting inside of it. It's a big open space, and there's windows up here. So that means that this part of the capsule is hollow. Down here, they pack all the life support systems and parachutes and all this other good... Well, parachutes are up here, but you get the idea. The whole idea is that the center of mass is lopsided. And that's part of the reason why roll control thrusters for the capsule are on the capsule. Roll control thrusters for Orion are on the capsule and not on the service module. because you need those roll control thrusters when you go to land. That's really, or go for EDL, I should say, entry, descent, and landing. The roll control thrusters don't do much after the parachute's deployed. I mean, you could do it, but... So, you have a capsule with a lopsided center of mass coming in for re-entry. If you roll the capsule, you can effectively change the angle of attack of the heat shield, and you can steer the capsule in. This works in Kerbal. You could do that in KSP. Put a big counterweight on one side of the capsule and then roll it and see what happens. Ooh, neato burrito. Orion is not designed for reusability, right? Or are they planning to do that later down the road? Orion can be reused. They're reusing components from this one, just components. NASA works slow. They don't work like SpaceX. It's not reuse the whole thing. It's reuse one component, qualify it, reuse the next component, qualify it, etc., etc. You got to go slow. Look at that. So that cluster right there is a translation thruster. Interesting. ESM RCS paper. Yeah. When is SpaceX going to the moon? When Starship starts flying, it should be happening relatively quick, Elon. But other than that, I don't really. They're not Muskrat. That was not Elon Muskrat. That was Genesis. Other than that, I don't really know. Muskrat, what was your last? Why is it cosine rather thrust law rather than sine thrust law? That's a good question, man. That's a good question. I think it's... I forget. Frick. I forget. Damn it. You stumped me. I don't remember. I don't remember why you use cosine over sine in that particular scenario. I think it has to do with how the force is being applied, but I'm not sure. Cosine maximizes the values for small angles. It's the component of force in the direction versus the other. Yes. Okay, so I was on the right track. Sweet. There you go. Sokotoa. Yeah, gosh, Sokotoa. Man, I really wish I paid more attention in school. If you're in high school watching this, go do math. You need to learn how to do that if you want to work on spacecraft. Just remember the end goal. That's my big... Remember the end goal. You want to do cool stuff like this and not just do it in Kerbal and get to talk about it all day, which probably is not going to happen. You actually want to go work on this stuff, you have to be good at math. Math is not too bad. It's not too bad. Don't build it up in your mind as this impossible concept. That's what I did. Don't do that. Bad idea. Cool. How's your math? My math skills suck, Genesis. Terrible. Now, they're not the worst, but they're not the best either. Two plus two chair. John Hancock. It's Herbie Hancock. So I know capsules are offset. Is Dragon the same thing? Look at how Dragon floats in the water, T-Man, and you tell me. Corn! Sine theta. Thrust is the vertical component, and cosine theta. Thrust is the component normal to vertical component. So cosine loss is the amount of thrust you're losing in the cosine direction. Oh, it's orientation. There you go, Novus. Yeah, guys, my math is pretty bad. It's not the best. Here's the thing. It's not that I'm bad at doing math. You've seen me do math many times on the stream. I'm not bad at doing math. I just don't know what the frick you would need to do to figure out, any type of math. But that's also to say that I wouldn't be able to not learn it, you know? I know I could learn it. You just got to go do it. That's the real one. Math is not too bad. It's not too bad. It's just like learning another language. You just learn the syntax. Once you get the syntax and know where to apply certain formulas in certain areas, then you're fine. Calculus is becoming both my favorite and most despised topic right now. All right, Violent. Have a fun stream. Thanks for answering your questions. My pleasure. Do you know Ohm's law? Isn't Ohm's law resistance with electricity? Yeah. EIR, VIR, yes. I'm sorry, I lost my train of thought because of chair. I'm not even kidding. Oh boy. Oh, by the way, page 3 has info on the Artemis 2 mission profile. Ooh. Oh yes. I freaking lost my train of thought. The damn chair thing threw me off, dude. I'm not even kidding. Smells like math in here, you damn nerds. Good evening. Been watching, listening all day. Drove back to college for finals after Thanksgiving. Sweet. Oh. Dude, EM2 is going to be hardcore. Well, Artemis 2. That's going to be insane. Oh, this mission. You think Artemis 1 is good? 2 is going to be awesome. That's going to be pretty freaking cool. Last math class I took was 20 years ago, my first semester in college. Yeah, kind of rusty here too. Yeah, it's just kind of like the syntax. That's basically what I was saying, Sniper. Math is just syntax. It's just like learning a language. Learning a language is fine. You could do it. You just keep speaking it and you'll get better at it. It might take you a little bit longer to learn it than other people. Not you, Sniper, but it might take you a little bit longer to learn it, but if you just keep doing it, you're going to get better at it. That's something that's really important to understand, especially if you're younger. Dude, who gives a flying frick if you don't learn it as fast as the other guy? That was my problem. I don't learn fast. I'm a very slow learner because I need to see the whole thing working. If I don't see the whole thing working, it doesn't really make sense in my head, right? At least that's how I was at the time. So I would see that other kids would learn so much faster than me, and I was like, oh man, I'm stupid. I'm an idiot. I can't learn this stuff as fast. So me being an idiotic 15, 16, 17, 18-year-old just said, screw it, I'm going to go play video games. I'll never learn this. This is stupid. It's a waste of my time. Remember how I said that history is a good way to see what not to do? Don't do that. Don't do that. I'm still confused about how the N can get Orion to TLI this way. With a rocket engine is the answer. Is it true that calculus credit in college actually counts as foreign language credit? I don't know, Builder. Yeah, too late. Yeah, well, it's never too late. Now look at him here, teaching without a degree. Shut up, man. Yeah, that's the thing, man. I'm not saying stuff in your mind that makes sense. It's just sometimes you have a thought and you think about it in your head and then you say it out loud and you're like, wow, that's a really stupid idea. Damn. Since we are on the subject, can you please explain an Ohm's maneuver? Orbital maneuvering system. An Ohm's maneuver is just something that the space shuttle or Orion, this is called the same thing, uses to maneuver around in space. That's all. It's just the engines. Firing the engine. Surface propulsion system. Fire the rocket engine. College calculus, that was that way for me. I understood it, but could not grasp it all before we moved on to the next rapid fire topic. Yeah, Tin Hat Dave, it's a shame that stuff kind of happens. Oh, nice flagging. That's cool. Yep. Firing my laser. Yeah, crazy. He's a chairless man, still not a man. But yeah, guys, just make sure you can learn math. It's just going to take a second. But here's the thing. You know, if you need help learning something, you can always ask. No teacher is going to say no if you said, I didn't understand this. Can you please help me explain it? Stay after school if you have to. Whatever. Dude, if I could go back to high school now with the benefit of not giving a flying frick what people think about me, oh, I would be there. Dude, I'd be there every day after school. Every day. Every day after school. If I didn't learn something, I'd be like, teacher, I'm not staying after school with you. You're staying after school with me. Yeah, that's what I would do. And any teacher that tells you no doesn't deserve the title. Yeah, if the teacher says, well, I'm too busy, frick them. They're not a teacher. Go to the principal and be like, yo, this teacher said no. But on the other hand, Aqualux, you're right. You're absolutely right. That's why I try to answer every freaking question. I will answer everything. I don't care how long it takes. Here's the thing. Kids will use that as an excuse for the teacher to hold their hand through every single thing. If you want to sit there and you want to learn, you got to remember that you got to figure some of this stuff out. I got them, by the way. You got to figure some of this stuff out on your own. You can't just sit there and have the teacher hold your hand all the time, because if they do and they just literally spell out every single freaking thing for you, you're not going to learn anything, because the teacher's the one doing the work and not you. Can you please answer my question? Why? Why not? And this is why I do exercises like this, where I don't just ask a question. Like what we were doing with Orion just a second ago. And I even throw in curveballs just to see who's paying attention. You know what I mean? This doesn't ring true with my college professors. Most of mine didn't have available office hours for you. I don't know if this necessarily applies to college professors. This is more high school and middle school stuff. Yeah, with college, yeah, good luck with that one. But just remember, the teacher isn't going to be there at your beck and call. They're not your freaking butler. Okay? You do have to learn this stuff as well. That's really important. I remember I had an English teacher one time talk to us about this, and it actually kind of knocked a couple screws loose in my head. My English teacher basically said at the time, he said, look, my job here is to teach you the subject matter. If I don't make it entertaining, I'm a bad teacher. I'm here to cater to you. I have to cater to you instead of actually just teaching the subject matter. And I thought about it and I'm like, oh, he's right. Really wish someone had told me that like when I was in 6th grade as opposed to 12th grade, but hey, whatever. I was like, damn. I'm treating this like I'm a TV show. If I'm not entertained, I don't care. That's not how you learn. Well, you committed murder on stream. It was a mosquito. Now, don't get me wrong. It helps if you make it interesting. I like to think that I make it interesting, but it's really about relating to source material. That's why I teach via analogy all the time. Talking about cars. Because everyone knows what a car is. I was going to say everybody knows how a car works, but not everybody knows how a car works. Hey, roundabout 23-month resub. Would be a lot smarter as a country so anti-nerd and too cool for school attitude. Yeah, Sparrow, I try to curb that. Do I look like a nerd to you? Dude, I confuse the hell out of my neighbors. I confuse the hell out of my neighbors because I have this on my freaking desk. I have this on my desk and that in my garage. I had some neighbors over the other day and he was like, how did you have that in your garage and you talk about rocket science all day? Who are you? I'm like, I don't know. I don't know what you're talking about, man. I just really confused the hell out of my neighbors. That applies to college too. It'd be more organized, but they still should be available. I mean, Aqualex, yeah, I mean, I think that's a good argument to make. The reality of the situation is different, but I think it is a good argument to make, especially because you're paying for it. You know, that there's that whole paying for it thing. I work for Amazon. Bingo. Bill, that's it. It's it in a nutshell. They're like, how? Like, dude, one of my neighbors is like, yeah, you're a rocket scientist, huh? Freaking rocket scientist over here. I'm like, I'm not a rocket scientist, man. I'm like more closer to like a spaceflight journalist. Rocket scientist. I'm like, nope, that's not what. All right, sure, why not? Okay. just yeah. I'm not saying you specifically. More talking about young kids worrying about more likes on their Instagram and stuff like that. Oh yeah, no, that. Sparrow, I'm with you. I'm with you on that one. But the reason why I brought it up is because, dude, I'm just a regular dude. I'm just a regular dude that decided to that I wanted to learn the most complicated freaking thing around. And that's what the vast majority of rocket scientists are. They're just regular freaking people. That's why I brought that up. What did you do before Twitch? I worked on a loading dock at a Best Buy, Wazzy, on paper. Yeah, MV, exactly. Yeah. I worked on a loading dock. If you want to know how bill of ladings work, I can teach you that if you really wanted to. Actually, you know what, man? You know what the messed up part is? I actually enjoyed that job. I enjoyed working on a loading dock until the people that I was working with kind of ruined it. But that's another story. And then myself as well. But I'm not totally not at fault there. I'm not gonna lie to you. I actually enjoyed that job. You learn logistics chains and how supply chains work, working on a loading dock. It's really cool, actually. You know, like, okay, take Geek Squad, for instance. You send your TV at Geek, you know, if you're at Best Buy and you have your TV and it's broken and you bring it to Geek Squad and you're like, hey, fix it, please. They ain't fixing it right there. They ship it out. And then it goes into a truck. And that truck goes to an RDC, a regional distribution center. And that regional distribution center goes to a servicing center. It goes from another truck from the RDC to the service center. Like a dedicated Geek Squad facility where they actually do fix the stuff. And then they put it back together. And then from the service center, it goes back to the RDC. And from the RDC, it goes back to the store. And from back to the store, it goes to Geek Squad. That's just one thing. They do that with washing machines. They do that with TVs. They do that with cameras. They do that with everything. That's that protection plan thing that they push on people all the time that's really annoying. And you're like, no, I'm not interested. And then you lose even if you buy it, you lose the damn receipt. You know what I mean? And whatever. Like, there's a whole system there. There's a whole system, and it's been carefully engineered for optimum efficiency. And I actually think that's really cool. That's really interesting to me. It's like playing Satisfactory. Bill of lading suck. I mean, hi, sign here, please. You've worked on a loading dock. Well, in some capacity or not, but yes. You do for rocket science what I would be happy to do about practical aviation knowledge. Dude, we could dive into planes, Sparrow. I used to do a segment called Wings Wednesday where we just messed with planes in Kerbal for a lot. We should do that again. Maybe not just like dedicated build a plane. Maybe just build a plane and have some fun. I'm sure you guys are all going to say yes. The Shatter's like, planes? Planes? Big thing you got to learn about planes. Where the center of gravity is. And then this one is kind of the second part is kind of a 4-part thing. Lift, drag, thrust, and gravity. That's it. Those are the basics. Last, please. Play Microsoft Flight Simulator. Yeah, maybe. I got to reinstall it. I uninstalled it. I just got an idea for a hoodie. White hoodie and Canadarm logos on the sleeves. Nice. My life is Bill of Ladings. Yep, gravity. Wait, sure. And money. Yeah, okay, that would be the third part. Money, yes. Make a helicopter again? Did you ever build an F4U? No, I didn't. Actually, the helicopter deep dives that we did, including taking our test helicopters and diving them into the ground, yeah, that taught me a lot about mechanical things and how mechanical things work and why mechanical things are the way that they are. You also have a Canada arm concept. No. No, you don't. Or the meme version. Dreams, reality, money, FAA. Yep. The swash plate. Swash plates are insane, dude. Insane. But Chief, that deep dive into helicopters and stuff really taught, what that taught the most to me amongst anything is how balanced rotating assemblies need to be balanced or else they will precess. And if you have precession in a rotating assembly, it breaks. Yeah, it ceases to rotate. Yeah, that's kind of important. Hey Vickers, welcome back. I hope you had a good Thanksgiving. Did they static fire? No, static fire didn't go today. I may have fallen asleep due to the man flu. Yeah. Nah, it didn't. It didn't. But we did get this from the press conference this afternoon, which is pretty sweet. Well, okay, you got a streamer that you moderate for that would love to network with you. You both do car streams and are, for the most part, also STEM adjacent. He's a former Air Force mechanic and licensed helicopter pilot. Post his name in chat, Hokie. Yeah, post his name in chat. Shattermaids may know who you're talking about. I'll bet you I know who it is. Malik VR. I don't know who that is at all. But yeah, dude, absolutely. What kind of cars does he... Wait, okay, Hokie, this is important. What kind of cars does Malik have? Yeah, Ernock. Yeah, the guys on the loading dock are cool. Mods, let's get a plug for Malik. Malik _ VR in chat. Go. He has a Miata and an RX-7. Ooh. Hokie, tell him... Ha 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 ha. Spinning Dorito. Cool. All right. It's Spinny Dorito boy. He's a man of taste. Spinning Dorito. What model RX-7? Yeah, Shutsy's right. What model RX-7? Headlights go up. Headlights go down. Headlights go up. Headlights go down. Can vouch for Malik. Seen his stuff. You two would get along great. Sounds good to me, man. Hold on. Yep. Will you play Kerbal too? Yeah. Yeah, Genesis, absolutely. Yes. Oh yeah. No, we're doing that. Yeah. No, I'm gonna play the trash out of that game. Yeah, of course, man. Yes. Yeah. Oh, absolutely. Did you hear about the new rotary style engine someone is working on? They aren't calling it a rotary, but it's based off one. Ah, yeah, Sparrow. I've seen that thing. It's the spinning kidney bean thingamajigger. Shout out was given to Malik _ VR. Wait, you can do that? All right, I'm clicking on it. Is Malik streaming right now? Oh, he's not. He's not streaming right now. Factorio. Oh, my boy's playing Factorio. Nice. Factorio. Crafting. Elite. Flight Simulator. Yep. All right. Yeah, we're friends now. You should have said no. Let's be honest. You're going to be doing absolutely despicable things in that game. Oh, yeah. I know guys that will stay on the first version of the game. Genesis, I have input on the second version of the game, so I'll probably play it. Yeah. Malik's a cool guy. I used to play Elite with him a few years back. All right, Vic. Jeez, I'm surprised nobody's told me about him earlier. Nope, but he's planning on being on Elite all day tomorrow. He's planning on being all day tomorrow because of Elite Dangerous. Malik flies real good. All right. Immelman, name checks out. Cool. Sweet. Yeah, dude, we'll go see if we can network. a little bit. What's the streaming hours, Hokey? The Twitch shadow command is pretty neat. It also alerts a person who was shouted out with a message which shows how many people were in the stream when it was given. Oh. That's pretty neat. I've seen a lot of Malik streams where he whips out a whiteboard and teaches math and science that comes up in the channel. Sweet. Can he teach me math? How to math? We're going to learn a new thing today, dudes. It's called math. And without it, none of us would exist. Test. Loud and clear, Shatter. How copy me? Usually EU times. The early day streams. Large amount of his viewership are EU. I'm excited for SpaceX when they use the claw to catch Starship. Dude, I'm with you. I'm with you on that one. That catch is going to be legendary. Where's my whiteboard? Bob Lazar was also arrested for being a small-time pimp, which makes perfect sense. Wait, why are we talking about Bob Lazar? Hey, Bandit. Yep. EJ's whiteboard is Maya. No, it's paint, dude. Also, Dodge is replacing Hemis with a straight 6 turbo. You know what, Figs? Let me put it to you like this. If you were going to replace a Hemi with any other type of engine, I would say replace it with a straight 6 turbo. Yeah. If it had to be replaced, it's dual overhead cam, right? And it's an inline 6. It's not a V6, right? Like inline 6, like 1, 2, 3, 4, 5, 6. Not this. GM is replacing all the Colorado engines, including the little Duramax, with a single 2.7 liter inline 4 block. See, Chevy is making a 4-cylinder truck. 2.7 liter inline 4 is nothing to start that. That's pretty big. Pokey gifted a sub to Shatter Mage. Meanwhile, you basically have a telestrator that you don't use. Why don't you tell us shut the heck up? It's a 2JZ. That's what I'm getting at, Papa. Is like it's not this, right? It's this. Yeah? Not this. Not this. I don't like this. This is bad. It's this, right? Inline. There's an engine concept that I saw 10 years ago that I was wondering if you knew about. Basically looks like a revolver barrel with what you might describe as a swash plate. Pistons go up and down as they rotate around a central axis. Haven't been able to find it in years. I think that was a Toyota concept. How long until someone takes 2 of those inline 6s and makes a twin-turbo V12? The only downside is that it's designed by AMC 242, slant 6, leaning tower of power. Hey, Mopar has a very rich history of making great inline 6 engines. Pentastar, not an inline 6, bro. Not an inline 6. Hang on, how have I never known you don't like V6s? Because V6s are terrible. Don't get me wrong. V6s are cool. They make good amount of power, and if you turbo it, it's great. The problem with V6s is that they're inherently unbalanced. You are leaving power on the table because you decided to stack your cylinders like this. The V6 are very unbalanced designs. They make a lot of vibrations. No good. Don't get me wrong. You could precision machine one to be nice and smooth. But an inline 6 is very smooth because the front piston and the rear piston are perfectly synchronous. The second piston and the fifth piston, perfectly synchronous. Third piston and the fourth piston, perfectly synchronous. It is perfectly balanced. And when your motor is perfectly balanced, more of that force can be used to push that piston down and not to the side or, not rocking the motor back and forth. It's a very smooth operation. That's why people like 2JZs. That's why people like RB26s. V8s are very balanced, are balanced for the same reasons but see, here's the thing, Chief. V8s are only balanced to a certain extent. With a V8, you could use like a flat plane crank with a V8 and you got to get the pistons synchronized. So on a V8, you have to get this piston aligned with this piston over here. They have to be going down, up and down at the same rate. If they don't, the V8's just going to rock back and forth. And I'm telling you, if the piston is getting pushed down and the engine gets rocked sideways, forward and back like that, some of the mechanical work that piston is generated is moving the engine around. That's inefficient. You're leaving power on the table that way. Semis are inline sixes for a reason. Yep. Someone say RB26? Yeah, TJ, I want to. 5M GTE. Same. Yeah. So the 7M, the 5M, that's why people like 2JZs and 7M GTEs and 5Ms and 3M GTEs if you really want to go way back. RB26s, RB25s, that's why people like those engines. Heck, those Jeep motors, those 4-liter Jeep motors and Ford's 4.9 inline 6, there's a reason why why you make an inline 6, because inline 6s can be used, they make the most amount of power. They don't make a lot of torque, but if you have a high displacement inline 6, they'll make power and torque, sure. But here's the thing. If you have a gigantic inline 6, you're not going to be able to rev pretty high. You're not going to be able to rev high, which is why, Ernock, you said that a lot of inline 6s are truck engines, which is why inline 6 diesel motors are king, like a 6BT Cummins. They make torque for days, but they don't rev very high. Have you any pieces of the space station that you're making? The Artemis press conference and kind of ruined that. We'll start on the space station components tomorrow. I had a little bit of a problem that I needed to fix with the shuttle today, Cody, that I found. I found some gremlins in the craft file, and that's what kind of took up a lot of my time. Muskie, 22-month resub. They're saying a 3-liter twin turbski's low output will put out about 400 and 425. High output is 500 plus. Your 15L red line's at 2200, but it makes 2,000 foot-pounds of torque at 1100. Yep. Yeah. Inline 6s, low displacement inline 6s can rev to the end of time. Like an RB26. Or a 2J. Or a 1J. Or a 7M. They all rev for days. Once you start getting into higher displacement inline 6s like a Barra or Ford's 300, they don't really rev as much. Once you get into really big displacement like truck engines that are 15 liters, yeah, they don't rev very well, but they make lots of torque. 195 horsepower for a 4-liter inline 6 just wasn't working anymore. But that 4-liter inline 6 Orion is not designed to make power. It's designed to make torque. And the reason why they lasted forever, and the reason why Ford 300 inline 6s last forever, is because the design is balanced. You don't wear on any of the components as long as you change the oil. And even then, they don't care. Low displacement, endless rev. F1 cars idle at 5K. Yep. That's cool, man. Figs, I'm in. That's cool. It's going to be a shame that Chrysler isn't going to make Hemis anymore, but whatever. Oh, speaking of that. Is this the Chrysler we're talking about? Because I went by their world headquarters the other day. I didn't stop. I just went by it. Oh, there's also this. I found these, by the way. Don't ask me how. I've never seen them before. I found them at some random shop in Michigan. Malik is an 87 FC non-turbo RX-7. 13B? 13B, right? 13B? Put them in the fridge. Okay. Probably smuggled by Canadians. Maybe. I can get Tim Tams anywhere in the Midwest. Yeah, me too, apparently. Anyway, all right, dudes. What time is it? It's 9 o'clock. That was a fast 9 hours, dude. Yeah, there you go, Storm, right on. Looks like the base model, but it has some mods. Yeah, they're still cool. Hokey, those Wankel engines can rev really, really high. If you build them right, they can rev over 10,000 RPM easily. Easily over 10. Easily. The reason why is because with a Wankel, there's no stroke. It's just a Dorito-shaped thing rotating around in a case. And because it's not rotating very far, the stroke is not very high. But the displacement is pretty freaking high for what it is. I mean, you can't really measure this in displacement, bore, and stroke. It doesn't really work that way. You have to use combustion chamber volume, but either way, the combustion chamber volume to stroke on a car like that on those Wankel engines is ridiculous. So, like, it's really short stroke, so to speak, but even a 2-liter. What's a 13B? It's 1.3 liters, right? Those things, because they can rev so ridiculously high, the displacement doesn't matter. You're going to make power. They're fragile. Yeah, apex seals. Scale model engine builders have gotten small scale rotaries to nearly running at nearly 40,000 RPM. It's crazy. 1.2 liters. Yeah, you can make like 300 horsepower out of a 1.2 liter because it can rev forever. Apex seal maintenance was not fun, but man, I love the rotary. Yeah. Yeah, Kuro. Yep. Volcano news. Yeah, the Mauna Loa volcano erupted first time since 1984. Cool. I'd like to see 2-disc rotaries thrown into a small aircraft like Cessnas or Pipers. Weight savings compared to Lycoming engines should be nice. Thoughts? I wouldn't do that. Sparrow, yeah, weight savings would be great.
Discovery, go at throttle up.
But you got to remember that center of gravity makes a big difference with an airplane now, doesn't it? Yeah, swapping it out there, yeah, not on the center of mass. You'd move your center of mass back behind the rear gear if it was on like a Cessna. I think you'd put the plane down and it would fall backwards. It certainly does, but you could move the rotary forward to adjust the engine's moment. Yeah, but now that you change the moment on the engine relative to the center of gravity, the plane's going to handle completely different. I suppose as long as you took into account all that stuff, sure, it'd be fine. Yeah, RJ, I have it figured out. I know what I need to fix. It's the cubic octags. I've narrowed it down to the cubic octags, but we got the vessel hierarchy thing working. Yeah, that would mean FAA. Something FAA, something dreams, something money. TNT, that was a 58-monther. What about de-stroking an engine? So, goalie, de-stroking an engine is something that you'd want to do to... You make less power, but no. Hang on, let me remember now. Yeah, you'd make less power, but your engine would be able to rev higher. So you'd make less power in certain spots, but you'd be able to rev a lot higher. But see, it's not just bore. It's not just. Oh, you said de-stroking. I was thinking bore. So. No, you said what did you ask? Now I'm confused. What about destroking an engine? Destroking an engine? So destroking an engine, yeah, you won't make as much torque. You won't make as much torque. You're effectively destroking an engine is a, well, see, here's the thing. Yeah, you destroke the engine will be able to rev higher, but it really depends. That's just the lower end. The lower end will be able to move faster, but there's a lot of things you got to take into account there. And what type of engine it is. Like, particularly, what's your valve train actuation? With a pushrod motor? With a pushrod motor, yeah, you could destroke it. That's fine. The engine would rev a lot higher, but you're still going to get valve float at a certain RPM regardless. You'd have to screw with the valve springs and stuff. Hey, Pythos, thanks for the raid. Should be able to handle the same. Put the engine so that its moment is the same as the original equipment. Besides, center of gravity is a consideration when loading passengers and bags anyway. You're supposed to calculate that every flight. I know most people don't, though. Yeah. You won't necessarily make less power. It's more shifted. It's offset. You'll make power at different times. It's really, yeah, in Goli, that's really an application thing. Like, the reason why people put stroker kits in, like, okay, so take a 350. You put a 400 crank, small block 400 crank into a 350, and you make a 383, right? The reason why they did that is because they wanted to make a lot of power and a lot of torque with a lighter engine faster for the drag strip. That's why the 383 stroker exists. And also, Chevy is amazing at being able to take parts out of one completely different engine and put it in another. That's what makes Chevy cool, dude. Yeah, I'm saying that as a Ford guy. You can do that with Ford stuff to an extent, but not to the point that not the point that you can with Chevy. You can take Buick parts and put it on a Pontiac and it'll work just fine. Like, and I'm not talking like, oh, I'll take the alternator out, even though you can. You could like literally take pistons out of a Pontiac, put them in a Chevy with certain cars, and it would work just fine. Because GM is ridiculous like that. That's what they do. That's what made Chevy so cool, and that's why they have a lot of fans, because parts are really inexpensive, because there's a lot of them, and every part works with everything else. Oh, great. You have a truck that has a 350 in it, and you have a Camaro that has a 350 in it. The Camaro blows a rod because you messed with it. You could literally take a rod out of that truck, put it in the Camaro. No problem. You could take the crank, you could take the entire engine out of that truck, it'll bolt into the Camaro. As long as it's a small block. Heck, even if it's a big block, just change the motor mounts. Easy peasy. A 4.125-inch crank in the LS7 makes a 440 cubic inch engine. Because it's GM. Yeah, that's what they're good at. They're parts bin cars. All of them. And that's what GM did from like the early 60s all the way into the 90s. And to an extent, they still do it today with the LS engines. The block from my 2013 Sonic is still used in the 2023 tracks. That's cool, man. My 84 Ford Ranger has parts from a Toyota. That's what my dad did with his 70 Le Mans. He took the original motor and put Chevy racing parts in it to make it a better engine. Yeah, Birch. Mm-hmm. That's why Chevy has so many fanboys, dude. Because you could just take parts. You could take parts out of a Camaro and you could put them in a Corvette. I don't know why you'd do that, but you could. They're easy to fix. They're very old Chevys are very easy to fix. They're very easy to maintain. And if a part does break, you could just get parts from somewhere else for nothing. That's the reason why I like that box-style Ford truck out there. It's for the same reasons. Ford made that style of truck from 1980 to 1997. You can literally swap parts out. But we did run into problems with the gauge clusters. With it, if that was a Chevy, it wouldn't have been a problem. Why ruin a truck? It was just an example watching. Top of my head, center of gravity in a Cessna has about 8 to 10 inches of range. I mean, you could also trim it out. Sparrow, right? You could trim it out. But yeah, I mean, I don't know, man. On a Cessna, I suppose it wouldn't be an issue. I mean, it would have a really long nose. The thing would end up looking like you grafted a P-51 nose onto a Cessna. You could do it. I'm thinking, and I suppose that, like, with the speed that a Cessna goes at, it's not really that big of a deal, but kind of sucks, though, because Pontiac, Buick, and Olds blocks are actually very good pieces. Yeah, Hellfish, if I have to choose, Buick. I like Buicks. Yeah. Buicks is what my family like my grandpa drove a Buick around. Yeah. My dad was a Cutlass guy. My dad had a lot of Cutlasses. I want to try to buy him one of these days, an old Cutlass. I mean that when you calculate center of gravity and range in which it falls, it has about 8 inches of acceptable range when measured from datum. Is that 8 inches on center or 8 inches in well, it'd be front to back? Assessing we need a reduction gear to take full advantage of a Wankel, though. Okay. Transmission. We use pistons based on the Suzuki G16 and Honda Civic D16 for go fast bits. No way, Iger. That's cool, dude. D16s. I remember D16s. Olds 455, please. Yeah. That's cool, dudes. All right. Guys, we dumped about 9 hours on the day off stream. I could sit here and talk cars with you all day. I mean, in fact, we could do it if we wanted to change categories. I kind of still want to go strip more paint off the truck. There are LS swapped planes, though. Yeah, those LS swap planes are nuts. Sparrow, have you seen those things? Guy took a Bush plane and put a aluminum LS with a dry sump in it, and it's unreal.